Hello there, and welcome back to Sleepwalk Space. I'm so grateful you've returned to this quiet corner of the world, this space where wonder meets rest. Tonight, we're staying close to home, exploring the gentle mysteries of our own planet Earth. From the whisper of wind through ancient canyons to the slow dance of continents beneath our feet, from the patient growth of crystals deep underground to the delicate balance that keeps us all alive, Earth holds secrets that will soothe you, surprise you, and remind you just how extraordinary ordinary things can be. Some facts tonight might change the way you see your morning walk. Others will simply drift by like clouds on a summer afternoon, soft and fleeting, and somehow perfect. If these peaceful discoveries bring you comfort or spark your curiosity, consider subscribing. It helps others find their way here, one restful evening at a time. But for now, settle in. Let your shoulders drop. Take a slow breath, and let's begin this gentle journey through the most relaxing facts about the world beneath our feet and above our heads. Mountains are still growing taller. The Himalayas, home to the world's highest peaks, are not finished rising. Every year, they grow a few millimeters taller as the Indian tectonic plate continues its slow collision with the Eurasian plate. This has been happening for about 50 million years, and it will continue for millions more. Mount Everest, already the tallest mountain on Earth, keeps reaching higher into the thin air. It's a process so gradual you'd never notice it in a lifetime. Yet over deep time it reshapes the face of the planet. Other mountain ranges are growing too, the Andes, the Alps, the Rockies. All of them are part of Earth's slow, patient sculpture. The ground beneath you is not static. It moves, rises, and folds like a wave frozen in stone. And in this quiet movement, the Earth breathes. Rain smells like bacteria. That fresh, earthy scent after a rainstorm has a name, petrichor. It's one of the most beloved smells in nature, evoking nostalgia, calm, and renewal. But what you're actually smelling is a compound called geosmin, produced by soil bacteria called actinomycetes. When rain hits dry ground, it releases these molecules into the air. The bacteria produce geosmin as part of their life cycle, and humans are remarkably sensitive to it. We can detect it at concentrations as low as 5 parts per trillion. Some scientists believe our ancestors relied on this scent to locate water in arid environments. So when you step outside after rain and breathe in that cool, earthy sweetness, you're smelling life itself. Ancient microbes celebrating moisture, the quiet collaboration between earth and sky. Clouds can weigh over 1 million pounds. They float so effortlessly, drifting across the sky like cotton or dreams. But clouds are heavy. A single cumulus cloud, the kind you see on a sunny afternoon, can weigh more than 1 million pounds. How do they stay up? Because the water droplets are spread out over such a vast volume, and they're surrounded by air. Each droplet is tiny, and the air currents beneath them provide lift. Together, they float. It's a balance of physics, weight distributed so finely that gravity loosens its grip. And so the sky holds rivers, lakes suspended in the air, moving slowly, raining softly, reshaping constantly. When you lie on your back and watch clouds drift by, you're watching mountains of water glide silently overhead. The earth hums a note too low to hear. Deep within the planet, the earth vibrates. Seismologists have detected a constant hum, a low-frequency oscillation that never stops. It's far too low for human ears to detect, around 10 millihertz, but instruments can pick it up. The cause is still debated. Some believe it comes from ocean waves colliding with the seafloor. Others think it's related to atmospheric pressure changes or the movement of magma deep underground. Whatever the source, the Earth is always singing, a quiet note that resonates through stone, water, and air. It's a reminder that stillness is an illusion. Even when the world seems silent, it hums. And you, standing on its surface, are part of that song. Sand dunes sing. In certain deserts around the world, sand dunes produce a low, haunting sound when the grains slide down their slopes. It's been described as a hum, a rumble, or even a roar. This phenomenon, known as singing sand or booming dunes, occurs when sand grains of a specific size and shape rub together, creating vibrations that resonate through the dune. The sound can last for several minutes and be heard from miles away. Marco Polo wrote about it. Ancient travelers believed it was the voices of spirits, but it's just sand moving in harmony, a natural music created by friction, gravity, and time. In the stillness of the desert, the dunes sing their slow, deep songs. Glaciers carve valleys over thousands of years. When you stand in a mountain valley, steep walls rising on either side, you're often standing in the path of an ancient glacier. These rivers of ice move slowly, sometimes just inches per year, but with immense force. As they flow, they scrape, grind, and carry away rock, shaping the land into wide, U-shaped valleys. Glaciers are patient sculptors. Over millennia, they transform jagged peaks into smooth curves, sharp ridges into gentle slopes. Even after they melt, their work remains. Lakes fill the basins they left behind. Rivers follow the paths they carved. The landscape you see today was shaped by ice that moved long before you were born. Slow, silent, and unstoppable, glaciers remind us that even the softest materials can reshape the hardest stone. Rivers can flow backwards during eclipses. Not literally, but something remarkable happens. During a solar eclipse, as the moon's shadow sweeps across the Earth, the sudden drop in temperature can create unusual atmospheric effects. In some places, river currents slow or seem to hesitate. Tides shift. Animals grow quiet. It's as if the world pauses to watch. The river doesn't reverse, but the change in air pressure, wind, and temperature can alter flow patterns temporarily. Ancient people saw eclipses as omens, but there are also moments when the Earth itself responds to celestial choreography. The sun, the moon, and the planet, all moving in silent coordination. And for a few minutes, everything shifts. Soil takes hundreds of years to form. Beneath every forest, field, and garden lies a substance more valuable than we often realize. Soil. It's easy to think of it as just dirt, but soil is alive. It's a mixture of weathered rock, decomposed organic matter, water, air, and billions of microorganisms, and it forms incredibly slowly. Dependent on the climate and parent material, it can take anywhere from 200 to 1,000 years to build just 1 inch of topsoil. Rain, wind, plant roots, fungi, bacteria, and time all work together. They break down stone, recycle nutrients, and create the foundation for almost all terrestrial life. The soil you walk on today began forming long before your grandparents were born, and it will continue forming long after. Patient, essential, and often overlooked, soil is the quiet skin of the earth. The sky is blue because of the way light scatters. We see it every day, yet it still feels like magic. The sky, that endless dome of blue stretching from horizon to horizon. But why blue? Sunlight is made of all colors, and when it enters Earth's atmosphere, it collides with gas molecules. Blue light, with its shorter wavelength, scatters more than other colors. It bounces in all directions, filling the sky with that familiar hue. At sunrise and sunset, the light travels through more atmosphere, scattering away the blue and leaving reds, oranges, and pinks. The sky's color is not paint. It's physics, a daily miracle of scattering light, invisible particles, and human eyes that evolved to see it. And every time you look up, you're seeing the atmosphere itself, glowing softly in scattered sunlight. Caves grow crystals in the dark. Deep underground, where no light reaches, extraordinary things happen. In certain caves, minerals dissolved in water slowly precipitate out, forming crystals. Some are tiny, others are massive. In the Cave of Crystals in Mexico, selenite beams as large as trees fill a chamber, glowing pale and translucent. These crystals grew over 500,000 years in hot, mineral-rich water. They're delicate despite their size, and they formed in complete darkness, one molecule at a time. Caves are not empty voids. They're workshops of geology. Stalactites drip down from ceilings. Stalagmites rise from floors. And in the silence, stone blooms into beauty, unseen, unhurried, and utterly patient. Lightning strikes Earth 100 times every second. Somewhere on the planet right now, a storm is raging. And in that storm, lightning is striking. On average, Earth experiences about 100 lightning strikes every second, over 8 million strikes per day. Each bolt can reach temperatures hotter than the surface of the sun, around 30,000 Kelvin. The energy is released in a fraction of a second, heating the air so rapidly it creates a shock wave we hear as thunder. Lightning is a balance of charge between clouds and ground, a sudden equalization that lights up the sky. It's destructive, yes, but also essential. Lightning helps fix nitrogen in the atmosphere, making it available for plants. It's dangerous and beautiful, chaotic and necessary. And it never stops. Across oceans, mountains, and deserts, the sky crackles with ancient fire. Fossils are windows into lost worlds. Hold a fossil in your hand and you're touching time. This stone was once alive. It breathed, moved, ate, and existed in a world unimaginably different from ours. Fossils form when organisms are buried quickly, usually in sediment, and over millions of years, minerals replace the organic material. What remains is a stone replica, a memory written in rock. Some fossils are shells, others are bones, leaves, or even footprints. They tell stories of oceans where deserts now stand, forests where ice now spreads, creatures that no longer walk the earth. Paleontologists study these remnants, piecing together ecosystems, climates, and evolution. But you don't need to be a scientist to feel the wonder. A fossil is proof that life endures, changes, and leaves traces. Even after everything else is gone, islands are born from fire. In the middle of the ocean, where tectonic plates pull apart or magma breaks through, new land emerges. Volcanic islands form as molten rock cools and solidifies, layer by layer. Hawaii, Iceland, the Galapagos, all were born this way. The process is violent. Lava explodes from the seafloor, steam hisses into the air, and ash falls like snow. But over time, the chaos settles. Plants take root, birds arrive. Life colonizes the barren rock. An island is a new beginning, a piece of earth that didn't exist before, now hosting forests, beaches, and ecosystems all its own. And beneath the surface, the process continues. Somewhere in the Pacific, a new island is forming right now, quietly, slowly, rising from the deep. Rivers shape coastlines over time. Where rivers meet the ocean, something beautiful happens. sediment carried by the current spreads out, forming deltas, complex networks of channels, wetlands, and islands. The Nile, the Mississippi, the Amazon all create these fan-shaped features. Deltas are incredibly fertile, rich in nutrients and teeming with life. They're also fragile. Sea level rise, dams, and human activity can alter or destroy them. But when left to their own rhythms, rivers build land. They deposit silt and clay, one grain at a time, extending coastlines into the sea. It's a slow negotiation between fresh water and salt, between land and ocean. And in this borderland, ecosystems thrive, fed by the patience of rivers. Earthquakes release energy, stored for centuries. Tectonic plates don't move smoothly. They grind, stick, and strain. Over decades or centuries, stress builds along faults, locked sections of the Earth's crust. Eventually, the pressure becomes too great. The rocks slip, and in that sudden release, energy radiates outward as seismic waves. We call it an earthquake. Most are minor, barely felt, but large ones reshape landscapes, topple buildings, and remind us that the ground is not as solid as it seems. The Earth is always adjusting, always balancing forces we can't see, and when it shifts, even slightly, we're reminded of the immense power beneath our feet. Not malicious, just mechanical. The planet, doing what it has always done. Snowflakes are all unique because of their journey. No two snowflakes are exactly alike. It's a phrase so often repeated it feels like folklore, but it's true. Each snowflake forms around a tiny particle of dust in a cloud. As it falls, it encounters different temperatures, humidity levels, and air currents. These conditions influence how water molecules attach to the growing crystal. The result is a shape unique to that particular fall through the sky. Some are simple, others intricate, but each one is a record of its journey. And because the atmosphere is infinitely variable, no two paths are the same. When you catch a snowflake on your glove and look closely, you're seeing a tiny sculpture, made by physics, shaped by chance, and gone in moments. Deserts bloom after rare rains. The desert seems lifeless, a barren expanse of sand and stone. But beneath the surface, seeds wait. Some have been dormant for years, even decades, protected by tough coats and patient biology. When rain finally comes, the desert transforms. Within days, flowers blanket the ground in vibrant colors, yellows, purples, reds. Insects emerge. Birds arrive to feed. It's an explosion of life, brief and brilliant. This phenomenon, known as a superbloom, is unpredictable. It depends on the timing and amount of rainfall. But when it happens, the desert reveals its secret. It was never dead, just waiting. And in this patient resilience, there's a lesson. Even in the harshest conditions, life knows when to rest and when to bloom. The moon controls Earth's tides. Twice a day, the ocean rises and falls. This rhythm, so constant we barely notice it, is driven by the moon. As the moon orbits Earth, its gravity pulls on the water, creating a bulge. The Earth rotates beneath this bulge and we experience it as high tide. On the opposite side of the planet, inertia creates another bulge, another high tide. The sun also affects tides, but the moon, being closer, has the stronger influence. Tides shape coastlines, influence marine life, and have been used by humans for thousands of years to navigate and fish. It's a connection between Earth and moon, a gravitational conversation that never ends. And every time the tide rolls in, you're witnessing the pull of another world. Ancient trees hold climate records. In the rings of a tree, history is written. Each year, a tree adds a new layer of growth, visible as a ring in its trunk. Wide rings mean good growing conditions. Narrow rings indicate drought, cold, or stress. By counting and analyzing these rings, scientists can reconstruct climates going back thousands of years. Some trees, like bristlecone pines, live for over 4,000 years. The rings are archives of temperature, rainfall, and even volcanic eruptions. Dendrochronology, the study of tree rings, helps us understand long-term climate patterns and natural cycles. The tree doesn't write, it remembers, and in its silent growth, it carries the memory of every season it endured. Coral reefs grow incredibly slowly. A coral reef, vibrant and alive, seems almost instantaneous when you see it. But it's the result of centuries, even millennia, of slow construction. Coral polyps, tiny animals no bigger than a pinhead, secrete calcium carbonate to form their skeletons. Over time, these skeletons accumulate. New polyps grow on old ones. The structure expands, layer by delicate layer. Some reefs are thousands of years old. The Great Barrier Reef began forming around 20,000 years ago. Each piece of coral you see is the work of countless generations. Reefs are not just habitats, they're monuments to patience, and when they're damaged, they cannot quickly recover. They grow at the pace of geology, slow, steady, and vulnerable. Auroras are caused by solar wind. In the far north and south, the night sky sometimes comes alive with color. Curtains of green, pink, and violet ripple and dance across the darkness. These are auroras, the northern and southern lights. They occur when charged particles from the sun collide with gases in Earth's atmosphere. The sun constantly releases a stream of particles called the solar wind. When these particles reach Earth, our magnetic field guides them toward the poles. There, they interact with oxygen and nitrogen, releasing energy as light. The result is one of nature's most stunning displays. Auroras are a reminder that Earth is not isolated. We're bathed in the sun's breath, protected by an invisible shield, and lit by the collision of star and planet. Volcanoes create new land and enrich soil. Destruction and creation are two sides of the same process. When a volcano erupts, it can devastate everything nearby. Ash buries landscapes, lava consumes forests. But over time, volcanic soil becomes some of the richest on Earth. Ash breaks down into minerals that plants need. Lava weathers into fertile ground. In places like Hawaii, Indonesia, and Iceland, volcanic regions support lush vegetation and thriving ecosystems. The cycle is long: eruption, cooling, weathering, growth. But it works. Life returns, often more abundant than before. Volcanoes are not just agents of chaos. They're recyclers, renewing the Earth's surface, releasing gases that shape the atmosphere, and building mountains that touch the sky. Glacial ice holds ancient air. When snow falls in polar regions, it doesn't melt. It accumulates, layer upon layer, compressing over time into ice. Tiny bubbles of air get trapped in the process. These bubbles are time capsules. Scientists drill deep into glaciers and ice sheets, extracting cores that contain air from thousands of years ago. By analyzing these bubbles, they can measure past levels of carbon dioxide, methane, and other gases. They can learn what the atmosphere was like long before humans existed. Ice cores from Antarctica have revealed climate data going back 800,000 years. The ice remembers what the sky was like, and in its frozen silence, it holds evidence of Earth's changing breath. Canyons are carved by patience. Stand at the edge of the Grand Canyon, and you're looking at over 1 billion years of Earth's history. The Colorado River carved this vast chasm, cutting through rock layer by layer. It didn't happen quickly. Water, moving steadily over millennia, wore away stone. Rain, wind, and freeze-thaw cycles widened the gorge. What you see is the result of patient erosion, nature's slow chisel. Canyons exist all over the world, each one a testament to the power of persistence. Water doesn't force. It flows. But over time, it shapes mountains into valleys, stone into sand. And in that gentle, relentless motion, even the hardest surfaces yield. The Earth wobbles as it spins. Our planet doesn't spin perfectly. It wobbles slightly, a motion called axial precession. Over about 26,000 years, the axis traces a slow circle in space. This wobble affects which star appears as the North Star. Right now, it's Polaris. But thousands of years ago, it was Thuban. In the future, it will be Vega. The wobble is caused by gravitational forces from the Sun and Moon, acting on Earth's equatorial bulge. It's subtle, imperceptible in a human lifetime. But over deep time, it changes how we see the sky. The Earth spins, wobbles, and drifts through space, and even the stars seem to shift in response. Hot springs are heated by Earth's interior. In volcanic regions, water seeps deep underground, where it's heated by magma or hot rock. Under pressure, it stays liquid even at high temperatures. Eventually, it rises back to the surface, forming hot springs. Some are scalding, others are pleasantly warm. The water often carries dissolved minerals, sulfur, silica, calcium, which precipitate out, creating colorful terraces and pools. Hot springs have been used for bathing and healing for thousands of years. They're windows into the Earth's heat, reminders that just below the surface, the planet is still molten, still restless. And when you soak in a hot spring, you're warmed by the same fire that formed the planet billions of years ago. Pebbles on beaches are polished by waves. Walk along a beach, and you'll find smooth, rounded stones. They weren't always that way. Each pebble started as a sharp-edged fragment, broken from a larger rock, but waves tumble them endlessly, grinding them against sand and each other. Over time, the edges wear away. The surface smooths. What remains is soft to the touch, pleasing to hold. It's a process measured not in days, but in years or decades. The ocean is a patient sculptor, rounding rough things, softening hard edges. And each pebble is proof that even stone can be shaped by water, given enough time. Wind shapes sand into dunes. In deserts and along coasts, wind moves sand into flowing, organic shapes. Dunes form when wind deposits grains in patterns determined by speed, direction, and obstacles. Some dunes are crescent-shaped. Others form long ridges or star patterns. They migrate slowly, advancing grain by grain, sometimes swallowing roads or villages. But dunes are also beautiful. Curves that shift with the breeze, shadows that change with the sun. They're sculptures made by air, constantly in motion, never the same twice. And when you climb to the top of a dune and look out across a sea of sand, you're standing on a wave, frozen in time. Salt flats are the ghosts of ancient lakes. In deserts around the world, you'll find vast, flat expanses of white, stretching to the horizon. These are salt flats, the remnants of ancient lakes that dried up long ago. As water evaporates, it leaves behind dissolved minerals, mostly salt. Over time, these deposits build up into a hard, white crust. Some salt flats are so flat and reflective, they're used to calibrate satellites. Others create stunning visual effects, especially after rain, when a thin layer of water turns them into giant mirrors reflecting the sky. These places are harsh, nearly lifeless, and hauntingly beautiful. They're echoes of water, memories of a wetter past, waiting in silence. The atmosphere protects us every second. Above your head, the atmosphere is working. It filters out most of the sun's harmful ultraviolet radiation. It burns up meteors before they reach the ground. It holds in warmth through the greenhouse effect, preventing Earth from freezing. It distributes heat around the planet through wind and weather, and it provides the air you breathe. The atmosphere is thin, just a narrow shell around a rocky planet, but it makes all the difference. Without it, Earth would be as barren as the moon. With it, life thrives. Invisible, essential, and often taken for granted, the atmosphere is our shield, our blanket, and our breath. Geysers erupt on a schedule. In places like Yellowstone, geysers shoot boiling water and steam high into the air. Some erupt randomly, but others, like Old Faithful, are remarkably predictable. Water seeps into underground chambers heated by magma. Pressure builds as the water boils. Eventually, it forces its way up through narrow channels, erupting in a dramatic plume. After the eruption, the cycle begins again. The timing depends on the underground plumbing, how fast water refills the chambers, how much heat is available. Geysers are rare, requiring specific geological conditions. But where they exist, they're mesmerizing. A visible connection to the heat below, erupting on nature's clock. Permafrost holds ancient secrets. In the Arctic and subarctic, the ground stays frozen year-round. This permafrost can be hundreds of feet deep and thousands of years old. Trapped inside are plants, animals, pollen, and microbes from ages past. Some are remarkably well preserved. Mammoths have been found nearly intact, their flesh still frozen. Seeds extracted from permafrost have been successfully sprouted. But permafrost is also a concern. As it thaws due to warming temperatures, it releases trapped carbon dioxide and methane, greenhouse gases that accelerate climate change. The frozen ground is both archive and alarm, holding the past and shaping the future. Rivers carry the mountains to the sea. Every river is a conveyor belt, transporting sediment from highlands to lowlands. Rain and snowmelt wash soil and rock fragments into streams. These particles travel downstream, tumbling and grinding against each other. Over time, mountains are worn down and carried away, grain by grain, to be deposited in deltas, floodplains, and the ocean floor. This process, called erosion, has been reshaping the planet for billions of years. It's slow by human standards, but relentless. The river doesn't rest, and every pebble in its bed is on a journey from peak to sea, part of the endless cycle that sculpts the land. Meteor showers are Earth passing through comet debris. On certain nights, if you look up, you might see dozens of shooting stars streaking across the sky. These are meteor showers, and they happen when Earth passes through the trail of dust left by a comet. As the tiny particles enter our atmosphere at high speed, friction heats them until they glow, creating brilliant streaks of light. Most burn up completely, never reaching the ground. It's a cosmic reminder that space is not empty. We're moving through a cloud of ancient debris, remnants of ice and rock that once orbited the sun. And for a few nights each year, the sky fills with light, Earth sweeping through the memory of comets. The deepest caves go miles underground. Beneath the surface, hidden from sunlight, vast cave systems twist and descend into darkness. The deepest known cave, Veryovkina Cave in Georgia plunges over 7,000 feet below the surface. Exploring these depths requires technical skill, endurance, and courage. Cavers squeeze through narrow passages, wade through underground rivers, and rappel down vertical shafts. The environment is alien, silent, dripping, cold, but it's also full of beauty. Formations take thousands of years to grow. Minerals create colors and textures found nowhere else. And in some caves, unique ecosystems have evolved, creatures that have never seen light. The underworld is vast, and we've only begun to map its depths. Tides create tidal pools full of life. When the tide goes out, it leaves behind small pools of water trapped in rock, crevices. These tidal pools are miniature oceans, teeming with life. Sea stars cling to rocks. Anemones wave their tentacles. Small fish dart between crevices. Crabs scuttle across the bottom. It's a harsh environment. Temperature and salinity can change rapidly as the pool heats or evaporates. Waves can flood it with fresh seawater or batter it with force. But the creatures here are adapted. They're tough, resilient, and specialized. Tidal pools are windows into the ocean's edge, places where land and sea overlap, and life thrives in the balance. Rocks can move across deserts on their own. In Death Valley, California, large rocks appear to move across a flat, dry lake bed, leaving long trails behind them. For decades, it was a mystery. How could stones weighing hundreds of pounds move without human or animal intervention? Scientists eventually solved it. During rare wet winters, a thin layer of ice forms on the lake bed. Wind pushes the ice sheets, which drag the rocks along. The movement is slow, but over time the trails become visible. It's a perfect example of how unusual conditions can create seemingly impossible phenomena. The rocks don't walk, but they do move, pushed by wind, ice, and patience. Lakes can turn over, mixing deep and shallow water. Most of the year, lakes are stratified. Warm water sits on top, cold water below. But in fall and spring, temperature changes cause the layers to mix. This is called lake turnover. The surface cools, becomes denser, and sinks, pushing deeper water upward. Nutrients from the bottom are brought to the surface, supporting algae and fish. It's a seasonal reset, a circulation that keeps the lake healthy. Sometimes, in rare cases, turnover can release gases trapped in deep water like carbon dioxide or methane. But usually, it's a gentle, invisible process, the lake breathing in and out with the seasons. Fog is just a cloud touching the ground. On misty mornings, when visibility drops and the world becomes soft and muted, you're standing inside a cloud. Fog forms when air near the ground cools to the dew point, and water vapor condenses into tiny droplets. The conditions are the same as a cloud forming in the sky. The only difference is altitude. Fog can be thick or thin, patchy or widespread. It transforms landscapes, turning familiar places into something mysterious. Sounds are muffled, distances are uncertain, and for a few hours, the boundary between earth and sky dissolves. You walk through the air made visible, a cloud that came down to meet you. Stalactites and stalagmites take thousands of years to form. In limestone caves, water drips from the ceiling, carrying dissolved calcium carbonate. When the water evaporates, a tiny deposit is left behind. Over centuries, these deposits build up, forming icicle-like structures hanging down, called stalactites. On the cave floor, where the drips land, mounds form upward, called stalagmites. Eventually, they may meet, forming columns. The process is incredibly slow. Some grow less than a millimeter per year. To see a stalactite a foot long is to see thousands of years of dripping water, one drop at a time. Caves are galleries of patience, sculptures shaped by gravity, chemistry, and time. Sand is the most common material on Earth's surface. It's everywhere. Beaches, deserts, riverbeds, even in soil. Sand is made of tiny grains of minerals, usually quartz, worn down from larger rocks. Each grain has a story. It might have been part of a mountain, ground down by glaciers, carried by rivers, and tumbled in the surf. Sand is also incredibly useful. We use it to make glass, concrete, and electronics, but it's not infinite. Some places are running out of the right kind of sand, a reminder that even common things can become scarce. And every grain you hold has traveled far, shaped by time and the elements. The ocean floor is mostly unexplored. We've mapped the surface of Mars in greater detail than the bottom of our own oceans. Less than 20% of the ocean floor has been seen by human eyes or instruments. It's a vast, dark frontier, full of trenches, mountains, and plains we've never touched. The deepest point, the Mariana Trench, plunges nearly 7 miles down. At that depth, the pressure is crushing, the temperature near freezing, and light doesn't exist. Yet life thrives there. Strange fish, shrimp, and microbes adapted to conditions we can barely imagine. The ocean floor is Earth's last great wilderness, a world within a world, waiting to be discovered. Earthquakes can change the length of a day. When a massive earthquake strikes, it doesn't just shake the ground. It can shift the distribution of Earth's mass, and when mass shifts, the planet's rotation changes ever so slightly. After the 2011 earthquake in Japan, scientists calculated that the day became about 1.8 microseconds shorter. After the 2004 Indian Ocean quake, it was 2.68 microseconds. The changes are imperceptible to us, but they're measurable. Earth is not a perfect, unchanging sphere. It's dynamic, constantly adjusting. And every major shift in its crust leaves a tiny mark on time itself. Lightning creates glass in the sand. When lightning strikes sand, especially beach or desert sand, the intense heat can melt the grains. The result is a glassy structure called fulgurite. It often takes the shape of the lightning's path, a branching hollow tube frozen in glass. Fulgurites can be small or several feet long. They're fragile, beautiful, and rare. Each one is proof of a single moment when Earth and sky connected with unimaginable force. Collectors prize them. Scientists study them. But to find one is to hold a lightning bolt's echo, solidified and still. Rivers can flow under deserts. In some of the driest places on Earth, water flows underground. These hidden rivers move through porous rock or ancient riverbeds buried by sand. You can't see them from the surface, but they're there, sustaining oases, feeding wells, and supporting ecosystems. In the Sahara, aquifers hold water that fell as rain thousands of years ago, back when the desert was green. Plants and animals in these regions depend on this hidden moisture. It's a lifeline beneath a lifeless-looking landscape. And it reminds us that even deserts are not truly empty. Water, that essential ingredient, finds a way to persist. The sky glows faintly at night. Even on a perfectly clear night far from city lights, the sky is not completely dark. There's a faint glow called air glow, caused by chemical reactions in the upper atmosphere. Atoms and molecules, energized by sunlight during the day, release that energy slowly at night as light. It's too faint to notice with the naked eye, but cameras can capture it. Airglow creates a soft, greenish or reddish hue across the sky. It's not pollution or reflected light. It's the atmosphere itself, glowing gently, a reminder that even in darkness, the planet is alive with invisible processes. Icebergs can be striped with color. Most icebergs are white or blue, but some have stripes of green, yellow, brown, or black. These colors come from different things trapped in the ice. Algae can create green bands. Sediment adds brown or black. Clear ice with few bubbles appears blue. The stripes form as layers of ice with different contents are compressed and tilted over time. When the iceberg calves off a glacier and floats into the ocean, these layers become visible. Each stripe tells part of the story of how the iceberg formed, where it came from, and what it picked up along the way. They're floating artworks, painted by time and geology. Wind can carve stone into sculptures. In deserts and badlands, wind doesn't just move sand. It shapes rock. Over time, wind-blown sand acts like sandpaper, eroding softer layers and leaving harder ones behind. The result is surreal formations, arches, hoodoos, mushroom rocks, and towers. Each one is unique, shaped by wind direction, rock composition, and countless years of patient erosion. These natural sculptures stand as monuments to the power of air, proof that even the gentlest force, applied long enough, can reshape stone. Underground rivers carve enormous caverns. Beneath the surface, water flows through cracks in rock, slowly dissolving limestone and other soluble stone. Over millions of years, these cracks widen into tunnels, then chambers, then vast caverns. Some underground rivers are small streams. Others are wide and powerful, flowing through darkness toward the sea. In places like Mammoth Cave in Kentucky, over 400 miles of passages have been mapped. Boats can float through some sections. In others, you must crawl. These hidden waterways are sculptors, architects of the underworld, creating spaces humans rarely see, but that hold immense beauty. Rainbows are circles. We just see arcs. When you see a rainbow, you're seeing only part of a full circle. The rest is hidden below the horizon. If you were in an airplane or on a mountaintop with the right conditions, you might see a complete circular rainbow. The phenomenon occurs when sunlight refracts, reflects, and disperses through water droplets in the air. Each color bends at a slightly different angle, creating the spectrum we see. Every rainbow is personal. The droplets reflecting light to you are different from those reflecting to someone standing beside you. You're each seeing your own rainbow, a private arc of light painted by rain and sun. Sinkholes can open suddenly. In areas where limestone or other soluble rock lies beneath the surface, the ground can collapse without warning. Water slowly dissolves the rock underground, creating voids. Eventually, the surface can no longer support its own weight, and it falls in, forming a sinkhole. Some are small, just a few feet across. Others are enormous, swallowing cars, houses, even entire streets. It's a dramatic reminder that the ground is not solid all the way down. In Florida, sinkholes are common. In other places, they're rare but stunning. These sudden openings connect the surface world to hidden chambers below, and they reshape landscapes in moments. Wetlands filter water naturally. Marshes, swamps, and bogs might seem messy or uninviting, but they perform a crucial service. Wetlands act as natural filters, cleaning water as it flows through. Plants absorb nutrients and pollutants. Sediments settle out. Microbes break down contaminants. By the time water leaves a wetland, it's often much cleaner than when it entered. Wetlands also prevent flooding by absorbing excess water, and they provide habitat for countless species. They're among the most productive ecosystems on Earth, and yet they're often drained or filled in. To lose a wetland is to lose a living filter, a buffer between land and water. Frost creates delicate patterns on windows. On cold mornings, you might see intricate designs on glass, feathery or fern-like. This is frost, formed when water vapor in the air contacts a surface cold enough to freeze it directly, bypassing the liquid phase. The patterns depend on temperature, humidity, and tiny imperfections in the glass. Each window's frost is unique. The crystals grow outward from nucleation points, branching and spreading in fractal patterns. It's temporary art, gone when the sun warms the glass or the room heats up. But for a few hours, winter paints in ice, turning ordinary windows into galleries of ephemeral beauty. The Earth's crust floats on the mantle. Beneath your feet, the solid ground is not as solid as it seems. The Earth's crust is broken into tectonic plates that float on the semi-fluid mantle below. This movement is slow, just a few centimeters per year, but it drives earthquakes, volcanoes, and the creation of mountains. Continents drift, oceans open and close. Over hundreds of millions of years, the map of Earth completely changes. Pangaea, the supercontinent, broke apart. The Atlantic Ocean formed. India crashed into Asia, creating the Himalayas. The ground beneath you is on a journey, and it will continue moving long after you're gone. Bioluminescent bays glow when disturbed. In a few special places around the world, the water glows blue-green at night when you move through it. This is caused by dinoflagellates, tiny plankton that emit light when agitated. Kayakers paddling through these bays leave trails of glowing water. Fish darting below create bursts of light. Even a hand dipped in the water sparkles. It's a surreal, magical experience, like swimming through liquid stars. The brightest bioluminescent bays are in Puerto Rico, Jamaica, and the Maldives, but the phenomenon can occur anywhere conditions are right. A living light show powered by microscopic life. Erosion never stops. Every raindrop, every gust of wind, every freeze and thaw contributes to erosion. Rocks break down, soil washes away, coastlines retreat. It's happening constantly, everywhere, too slowly to notice in the moment, but powerful over time. Erosion is why old mountains are rounded and smooth. It's why river valleys deepen. It's why cliffs crumble into the sea. We try to slow it with walls and barriers, but nature always wins eventually. Erosion is not destruction. It's transformation. The material doesn't disappear. It moves, settles elsewhere, becomes soil, sediment, new rock. The earth recycles itself, endlessly reshaping its surface. Some beaches have black sand. Not all sand is golden or white. In volcanic regions, beaches can be black, gray, or even green. Black sand forms from basalt, volcanic rock that's been broken down by waves. The sand is often heavier than typical quartz sand, and it can get very hot in the sun. Iceland, Hawaii, and parts of New Zealand have stunning black sand beaches. The contrast between dark sand, white foam, and blue sky is striking. These beaches are younger than typical ones, geologically speaking. They're evidence of recent volcanic activity, a reminder that the Earth is still building and breaking down in an endless cycle. Clouds can predict weather changes. Long before modern forecasting, people read the sky. High, wispy, cirrus clouds often precede a storm system. Dark, towering cumulonimbus clouds bring thunder and rain. A ring around the moon, caused by ice crystals in cirrus clouds, suggests precipitation is coming. Even the smell of the air changes before rain, that earthy petrichor scent. The sky tells stories if you know how to listen. It's not superstition, it's observation. And though we have satellites and supercomputers now, watching clouds is still one of the most reliable ways to sense what's coming. Diamonds form deep underground under pressure. The diamonds in jewelry began their existence deep in the Earth's mantle, about 100 miles down, where temperatures and pressures are extreme. Carbon atoms, arranged in a crystal lattice, form the hardest natural substance known. Over millions of years, volcanic eruptions bring these diamonds closer to the surface, sometimes in rock formations called kimberlite pipes. Not all diamonds make it. Many are destroyed or remain hidden. But the ones we find are ancient travelers, formed in darkness and heat, carried upward by violence and polished by human hands into symbols of beauty. Rivers freeze from the edges inward. In winter, when temperatures drop, rivers don't freeze all at once. Ice forms first along the banks, where the water is shallower and slower. Gradually, the ice extends toward the center. The middle, where the current is strongest, is the last to freeze. Sometimes the surface freezes while water still flows beneath. In extreme cold, ice can build up into thick layers or create ice dams that change the river's flow. But even in the coldest winters, some rivers never freeze completely. The current keeps moving, hidden under a white crust, patient and persistent. Lava can flow faster than you can run. When people imagine lava, they often picture slow, glowing ooze. And sometimes it is. But certain types of lava, especially basaltic flows with low viscosity, can move quickly. During the 1977 eruption of Mount Nyiragongo in Congo, lava flows reached speeds of up to 60 miles per hour. That's faster than most people can sprint. Lava can also flow through underground tubes, emerging unexpectedly miles from the vent. It's a reminder that volcanoes are unpredictable and dangerous. But they're also creative forces, laying down new ground, building islands and enriching soil for future life. The midnight sun never sets in summer. In the polar regions, during summer the sun doesn't set. It circles the sky, dipping low near midnight, but never dropping below the horizon. This phenomenon, called the midnight sun, occurs because of Earth's axial tilt. For weeks or even months, daylight is constant. It disrupts sleep patterns, confuses animals, and creates an otherworldly atmosphere. In winter, the opposite happens. The sun doesn't rise, and darkness lasts for months. These extremes shape the ecosystems and cultures of the Arctic and Antarctic, places where time is measured not by day and night, but by the slow turn of seasons. Rock layers tell the story of Earth's history. Look at a cliff face or canyon wall, and you're seeing a timeline written in stone. Each layer or stratum represents a different period. The sediments settled, compressed and hardened over millions of years. Fossils within the layers reveal what life existed at that time. Volcanic ash layers mark eruptions. Changes in color or texture indicate shifts in climate or sea level. Geologists read these layers like pages in a book, piecing together Earth's past. It's an archive that stretches back billions of years, and every outcrop is a window into deep time. Snow can insulate the ground. In winter, a thick blanket of snow doesn't just cover the landscape. It protects it. Snow is full of air pockets, which makes it an excellent insulator. Beneath the snow, the ground stays warmer than the air above. Small animals like voles and shrews live in this subnivean zone, tunneling through the space between soil and snow. Plants remain dormant but protected from the worst cold. Without snow cover, the ground would freeze deeper, harming roots and hibernating creatures. Snow, often seen as harsh, is actually a shield, a soft layer that preserves life through the coldest months. The sun's light takes 8 minutes to reach Earth. When you see the sun in the sky, you're seeing it as it was 8 minutes ago. Light travels at about 186,000 miles per second, but space is vast. The sun is roughly 93 million miles away, so its light takes about 8 minutes and 20 seconds to reach us. If the sun suddenly disappeared, we wouldn't know for 8 minutes. During that time, we'd still see it shining, still feel its warmth. This delay is a reminder of the immense distances in space, even within our own solar system. We live in the past, always seeing light that has already traveled, already left its source. Ice ages have shaped the planet many times. Earth has experienced multiple ice ages, periods when ice sheets expanded far beyond the polar regions. The most recent, which ended about 11,700 years ago, covered much of North America, Europe, and Asia in ice. These glaciers carved valleys, created lakes, and deposited sediment across vast areas. Ice ages are driven by changes in Earth's orbit and axial tilt, small variations that alter how much sunlight reaches different parts of the planet. Between ice ages are warmer interglacial periods, like the one we're in now. The climate is not static. It's part of a long, slow cycle, one that has repeated throughout Earth's history. Hurricanes are powered by warm ocean water. A hurricane begins as a tropical disturbance, a cluster of thunderstorms over warm water. If conditions are right, low pressure, warm sea surface temperatures, and light wind shear, the system organizes. It draws energy from the ocean, evaporating water and releasing heat. This heat powers the storm, driving winds that spiral inward. The faster the winds, the lower the pressure at the center, and the stronger the storm becomes. Hurricanes are massive, complex systems, hundreds of miles across. They're also fragile. If they move over land or cold water, they lose their energy source and weaken. But over warm water, they can become some of the most powerful forces on Earth. Salt can preserve things for thousands of years. Salt is a natural preservative. It draws moisture out of organic material, preventing the bacteria and fungi that cause decay. Ancient peoples used salt to preserve meat and fish, and some of those techniques are still used today. In extremely salty environments like the Dead Sea or certain salt mines, organic material can be preserved for millennia. Mummies, ancient textiles, even butter have been found remarkably intact. Salt doesn't stop time, but it slows decay dramatically. In its crystals, the past can linger, waiting to be uncovered. Caves stay the same temperature year-round. Deep inside a cave, the temperature remains constant, usually matching the average annual temperature of the region above. In summer, caves are cool. In winter, they're warm relative to the outside. This stability makes them ideal habitats for bats and other creatures that need consistent conditions. Early humans also used caves for shelter, taking advantage of this natural climate control. The deeper you go, the more stable the temperature becomes. It's a reminder that just below the surface, the Earth's temperature is steady, insulated from the daily and seasonal swings we experience above. The Pacific Ring of Fire holds most of the world's volcanoes. Around the edge of the Pacific Ocean, a horseshoe-shaped zone is home to about 75% of the world's active volcanoes. This is the Ring of Fire, where tectonic plates collide, subduct, and grind against each other. The activity creates earthquakes and volcanic eruptions. Countries like Japan, Indonesia, the Philippines, and the west coasts of the Americas all lie within this zone. It's geologically active, dynamic, and sometimes dangerous. But it's also the source of fertile volcanic soil, geothermal energy, and stunning landscapes. The Ring of Fire is where the Earth's inner heat breaks through, shaping cultures and ecosystems for millions of people. Fog can be harvested for water. In some arid coastal regions, fog is a vital water source. Large mesh nets, called fog catchers, are set up on hillsides. As fog rolls in, tiny droplets condense on the mesh and trickle down into collection troughs. The water is clean and can provide drinking water for communities where rain is scarce. This technique has been used in Chile, Peru, Morocco, and other places. It's simple, low-tech, and effective. Fog, often seen as a nuisance or just atmospheric mood, becomes life-sustaining. And in the early morning mist, there's enough moisture to fill wells and sustain life. Crystals grow in specific geometric shapes. When minerals crystallize, they don't form random blobs. They grow in precise geometric shapes determined by their atomic structure. Quartz forms hexagonal prisms. Halite, or table salt, forms cubes. Pyrite can form perfect cubes or 12-sided shapes called dodecahedrons. These shapes emerge naturally, governed by the way atoms bond and arrange themselves. Crystals are nature's geometry, order arising from chemistry. And when you hold a crystal, you're holding a structure that formed according to invisible rules, a tiny demonstration of how matter organizes itself into beauty. Earth's inner core is as hot as the sun's surface. Deep inside the planet, about 4,000 miles down, lies the inner core. It's a solid ball of iron and nickel, about 1,500 miles in diameter. The temperature there is estimated to be around 5,400 degrees Celsius, roughly the same as the surface of the sun. The pressure is so immense that despite the heat, the metal remains solid. This core is what generates Earth's magnetic field through the movement of molten metal in the outer core. We'll never see it or touch it, but it's there, a blazing heart at the center of the world, keeping us safe from solar radiation. Rivers can change course over time. Rivers are not permanent features. They shift, meander, cut new channels, and abandon old ones. This process, called avulsion, happens when sediment builds up, floods carve new paths, or tectonic activity changes the landscape. Over centuries, a river can move miles from its original bed. Ancient civilizations sometimes had to relocate because their river moved. The Mississippi, the Yellow River in China, and the Indus have all changed course multiple times throughout history. Rivers are alive in their own way, constantly seeking the path of least resistance, reshaping the land as they flow. The poles are warming faster than the equator. Climate change affects the entire planet, but not equally. The Arctic, in particular, is warming 2 to 3 times faster than the global average. This is due to a feedback loop. As ice melts, it exposes darker water or land, which absorbs more sunlight, causing more warming and more melting. The effects ripple outward, changing weather patterns, sea levels, and ecosystems worldwide. The poles are sentinels, early warning systems for changes that will eventually reach every corner of the Earth. And what happens in the ice affects us all, even those who live thousands of miles away. Fossils can be found in unexpected places. Deserts that were once oceans hold the fossils of marine creatures. Mountains that were once sea floors contain ancient shells and coral. The Earth's surface is constantly being rearranged by tectonic forces. What was underwater millions of years ago might now be a mile above sea level. Fossils are clues to these transformations. They tell us where oceans once reached, where forests once stood, where life once thrived in places now barren. Every fossil is a traveler through time and space, a witness to the planet's endless reshaping. Raindrops are not teardrop-shaped. Despite what cartoons show, raindrops are not shaped like tears. Small droplets are nearly spherical, held together by surface tension. Larger drops flatten on the bottom due to air resistance as they fall, forming a shape more like a hamburger bun. Very large drops become unstable and break apart. The classic teardrop shape is a myth, but the truth is just as interesting. The shape of a raindrop is determined by physics, the balance between surface tension and air pressure. And every drop that falls is a tiny, fleeting sculpture, shaped by its descent through the sky. Earthquakes can trigger other earthquakes. When a large earthquake occurs, it doesn't just shake one area. The stress released can travel through the Earth's crust, sometimes triggering smaller quakes elsewhere. These are called aftershocks, and they can continue for weeks, months, or even years after the main event. In some cases, a large quake can even trigger another large quake on a nearby fault. The crust is interconnected, and movement in one place affects the whole system. It's a reminder that the ground is not a collection of separate pieces, but a single continuous shell, always adjusting, always responding to forces from within. The deepest part of the ocean could swallow Mount Everest. The Mariana Trench, the deepest point in the ocean, reaches about 36,000 feet below the surface. Mount Everest, the tallest mountain, is about 29,000 feet high. If you placed Everest at the bottom of the trench, there would still be over a mile of water above its peak. This hidden depth is greater than the height of any mountain. It's a realm of crushing pressure, near freezing temperatures, and total darkness. And yet life exists there, adapted to conditions that would destroy most organisms. The ocean's depths are Earth's final frontier, deeper and stranger than we ever imagined. Snowflakes can take hours to form. A snowflake begins as a tiny ice crystal formed around a speck of dust high in a cloud. As it falls, it encounters different temperatures and humidity levels. Water vapor freezes onto the crystal, building it outward in six-fold symmetry. The process can take an hour or more, depending on conditions. By the time it reaches the ground, it might have traveled through miles of atmosphere, each moment shaping its final form. And then, within seconds of landing, it begins to melt or sublimate, returning to the water cycle. A snowflake's life is brief, but its journey is long. Geothermal energy comes from Earth's heat. Beneath the surface, the Earth is hot. In some places, this heat is close enough to the surface to be useful. Water seeps down, gets heated by hot rock or magma, and returns as steam or hot water. We can harness this energy to generate electricity or heat buildings. Iceland gets most of its energy this way. Other countries with volcanic activity, like New Zealand, the Philippines, and parts of the United States, also use geothermal power. It's clean, renewable, and reliable. The Earth's heat, left over from its formation and sustained by radioactive decay, is a gift we're just beginning to fully use. Thunder is the sound of air expanding. When lightning strikes, it heats the air around it to extreme temperatures, hotter than the surface of the sun. This sudden heating causes the air to expand rapidly, creating a shock wave. That shock wave is what we hear as thunder. The sound travels much slower than light, which is why you see the lightning before you hear the thunder. By counting the seconds between the flash and the sound, you can estimate how far away the lightning struck. Thunder is not the lightning itself. It's the air's reaction, a sonic boom created by heat, pressure, and the speed of expansion. Mangroves protect coastlines from storms. Mangrove trees grow in coastal areas, their roots submerged in salt water. They're specially adapted to survive in this harsh environment, filtering salt and anchoring themselves in soft mud. But mangroves do more than survive. They protect. Their dense root systems absorb wave energy, reducing erosion and buffering inland areas from storm surges. They also provide habitat for fish, crabs, and birds. In areas where mangroves have been cleared, coastlines erode faster, and storms cause more damage. These trees are living barriers, gentle but strong, holding the line between land and sea. Soil is alive with billions of organisms. A single handful of healthy soil contains more organisms than there are people on Earth. Bacteria, fungi, nematodes, protozoa, and countless others live in the spaces between soil particles. They break down organic matter, cycle nutrients, and help the plants grow. Without them, the soil would be lifeless dust. These microorganisms are the foundation of terrestrial ecosystems, and they work constantly, invisibly, in the dark. When you dig in a garden or walk through a forest, you're stepping on a living world, complex, interconnected, and essential. Rain can clean the air. As raindrops fall, they collect particles from the atmosphere, dust, pollen, pollutants, and bring them to the ground. This is why the air often feels fresher after a rainstorm. Rain acts as a natural cleanser, washing the sky. In cities, this process can temporarily reduce smog and improve air quality, but it also means that pollutants end up in soil and water, which is why runoff can be contaminated. Rain doesn't destroy pollution, it moves it. But in the moment, standing in the aftermath of a storm, breathing in the clean, cool air, it feels like the world has been renewed. Icebergs can flip over. As an iceberg melts, its center of gravity shifts. If the balance changes enough, the entire iceberg can roll or flip. This can happen suddenly and violently, creating waves and exposing ice that was previously underwater. That newly exposed ice is often deep blue, incredibly smooth and strikingly beautiful. But it's also dangerous. Ships and researchers keep their distance because a flipping iceberg is unpredictable. These frozen giants are constantly changing, melting, breaking apart, and repositioning themselves. Even something as solid as an iceberg is never truly still. Mountains create their own weather. When moist air encounters a mountain range, it's forced upward. As it rises, it cools, and the moisture condenses into clouds and rain. This is why the windward side of mountains is often lush and green, while the leeward side is dry, a phenomenon called a rain shadow. Mountains act as barriers, dividing climates. They create microclimates, sheltered valleys, windy ridges, and snowy peaks, all within a small area. The presence of a mountain changes everything: temperature, precipitation, vegetation, and even the animals that live there. Mountains don't just stand, they shape the world around them. Rivers create oxbow lakes when they change course. As a river meanders, it curves back and forth across the landscape. Over time, the curves can become so pronounced that the river cuts through, forming a straighter path. The old loop gets cut off, forming a crescent-shaped lake called an oxbow lake. These lakes are common in floodplains and are often rich in wildlife. They're temporary on a geological timescale. Eventually, they fill with sediment and become wetlands or dry land. But for a while, they exist as peaceful, isolated bodies of water, remnants of a river's wandering path. Clouds have different names based on their shape. Long ago, people simply called them clouds, but in the early 1800s, a scientist named Luke Howard created a classification system. High, wispy clouds became cirrus. Puffy, heaped clouds became cumulus. Flat, layered clouds became stratus. Combinations and variations followed. Today, we have dozens of cloud types, each with its own name and characteristics. Learning to identify clouds is like learning to read the sky. Each type tells you something about the atmosphere, its stability, its moisture, its movement. And once you know their names, you see the sky differently. Permafrost can contain ancient viruses. Frozen for thousands of years, ancient microbes and viruses remain preserved in permafrost. As temperatures rise and the ice melts, some of these organisms are being released. Scientists have revived viruses from permafrost and found them still capable of infecting cells, though they target amoebas, not humans. It's a reminder that life, even in a dormant state, can endure for unimaginable lengths of time. The thawing Arctic is not just releasing carbon. It's opening a biological time capsule, one that holds mysteries and perhaps risks we're only beginning to understand. The Great Salt Lake is saltier than the ocean. In Utah, the Great Salt Lake has no outlet. Water flows in from rivers, but it only leaves through evaporation. As water evaporates, it leaves behind dissolved salts, concentrating them over time. The result is water far saltier than the ocean, sometimes reaching 27% salinity, compared to the ocean's 3.5%. Few organisms can survive in such extreme conditions, but brine shrimp thrive, and they support millions of migrating birds. The lake's level fluctuates dramatically with rainfall and drought. It's a reminder that even large bodies of water are fragile, dependent on the balance of inflow and evaporation. Lightning can strike the same place repeatedly. The idea that lightning never strikes twice is a myth. In fact, tall structures like skyscrapers and radio towers are struck many times, sometimes dozens of times per year. The Empire State Building is hit about 20 to 25 times annually. Lightning follows the path of least resistance, and tall, conductive objects provide that path. This is why lightning rods work. They offer a safe route for the electrical discharge, protecting the building below. Lightning is not random. It's predictable, following the laws of physics. And in places where conditions are right, it strikes again and again. Caves can have their own ecosystems. In some caves, life exists in total darkness. These are called troglobites, organisms that have adapted to live permanently underground. They're often blind, pale, and slow-moving. They rely on food that washes in from the surface or on bacteria that feed on minerals. Cave ecosystems are fragile and unique. Species found in one cave may exist nowhere else on Earth. Exploring these ecosystems teaches us how life adapts to extreme conditions, and it shows us that even in the darkest, most isolated places, life finds a way. Deserts can be cold. When people think of deserts, they often imagine scorching heat. But deserts are defined by lack of precipitation, not temperature. Antarctica is technically a desert, one of the driest places on Earth. The Gobi Desert in Asia experiences harsh winters with snow and freezing temperatures. Even hot deserts like the Sahara can drop below freezing at night. Without moisture in the air to trap heat, temperatures swing dramatically between day and night. Deserts are places of extremes, and cold is just as much a part of their character as heat. Water can exist in 3 states at once, at a specific combination of temperature and pressure, called the triple point. Water can exist simultaneously as ice, liquid, and vapor. For pure water, this occurs at 0.01 degrees Celsius and a pressure of about 601 pascals. It's a delicate balance, and it demonstrates the fundamental behavior of matter. Phase transitions are not always sharp, dividing lines. At the right conditions, boundaries blur, and all states coexist. It's a concept mostly encountered in laboratories, but it reveals something beautiful about the nature of water and the physical laws that govern it. The moon is slowly drifting away from Earth. Every year, the moon moves about 1.5 inches farther from Earth. This happens because of tidal interactions between the two bodies. The moon's gravity creates tides on Earth, and the friction from these tides gradually transfers energy to the moon, pushing it into a higher orbit. Billions of years from now, the moon will be much farther away, and its influence on tides will be weaker. Days will be longer too, because Earth's rotation is also slowing. The relationship between Earth and moon is not static. It's a slow dance, gently separating, but still bound by gravity. Volcanoes can create lightning. During a volcanic eruption, ash particles, rock fragments, and ice collide violently in the plume. These collisions generate static electricity, similar to a thunderstorm. When the charge builds up enough, lightning arcs through the ash cloud. The result is a phenomenon called volcanic lightning or dirty thunderstorms. It's spectacular and terrifying, bolts of electricity flashing through dark clouds of ash. Volcanic lightning is a reminder that nature combines its forces in unexpected ways. Fire and electricity, earth and sky, all colliding in a single violent event. The Earth's rotation is slowing down. Imperceptibly, day by day, the Earth's rotation is decelerating. The primary cause is tidal friction, the gravitational pull of the moon on Earth's oceans. This slowing is tiny, about 1.7 milliseconds per century, but over millions of years, it adds up. Billions of years ago, a day on Earth was only about 18 hours long. As the planet continues to slow, days will grow longer. Leap seconds are occasionally added to our clocks to account for this. Time itself is not constant. It's tied to the spin of the planet, and that spin is gradually winding down. Water is the only substance that expands when it freezes. Most materials contract when they cool and solidify, but water does the opposite. When it freezes, the molecules arrange themselves into a crystalline structure that takes up more space than liquid water. This is why ice floats and why pipes burst in winter. It's also why lakes freeze from the top down, creating an insulating layer that protects aquatic life below. If ice sank, bodies of water would freeze solid, killing most life in them. Water's unusual behavior is one of the reasons life, as we know it, can exist. A quirk of chemistry that shapes ecosystems. Wind patterns are shaped by Earth's rotation. Because the Earth rotates, moving air doesn't travel in straight lines. It curves. This effect, called the Coriolis effect, influences wind patterns, ocean currents, and storm systems. In the northern hemisphere, winds and currents curve to the right. In the southern hemisphere, to the left. It's why hurricanes spin counterclockwise in the north and clockwise in the south. The Coriolis effect is subtle, but it shapes the movement of air and water across the entire planet. It's a reminder that we live on a spinning sphere, and that rotation influences everything, from weather to the flight of a baseball. Peat bogs preserve bodies for millennia. In acidic, oxygen-poor environments like peat bogs, organic material decays very slowly. Bodies buried in bogs can be remarkably well preserved, their skin, hair, and even clothing intact after thousands of years. These bog bodies, found mainly in northern Europe, offer incredible insights into ancient life. Some show signs of ritual sacrifice. Others seem to have died by accident. The tannins in the peat tan the skin like leather, turning it dark brown. These preserved people are windows into the past, frozen in time by the unique chemistry of the bog. Coral bleaching happens when water gets too warm. Coral relies on a symbiotic relationship with tiny algae called zooxanthellae. These algae live inside the coral's tissues and provide it with food through photosynthesis. But when water temperatures rise too much, the coral expels the algae. Without them, the coral turns white, a process called bleaching. Bleached coral isn't dead, but it's stressed and vulnerable. If conditions don't improve, it will die. Coral bleaching has become more common as ocean temperatures rise, and it's one of the clearest signs of climate change's impact on marine ecosystems. Mountains erode, but they also rise. Erosion constantly wears mountains down, but in many places, tectonic forces push them back up. It's a tug-of-war between uplift and erosion. In young mountain ranges like the Himalayas, uplift is winning. The mountains grow taller. In older ranges like the Appalachians, erosion has had millions of years to work. They're rounded and much lower than they once were. Over deep time, mountains rise and fall, shaped by the slow battle between the forces that build and the forces that wear away. Nothing on Earth is permanent. Everything is always changing. Auroras make sounds. For centuries, people reported hearing the northern lights, crackling, hissing, or rustling sounds accompanying the visual display. Scientists were skeptical, since auroras occur high in the atmosphere, where sound shouldn't reach the ground. But recent research suggests the sounds are real. They may be caused by electrical discharges near the ground, triggered by the same geomagnetic disturbances that create the lights. The sounds are rare and faint, but they're there. The aurora borealis, already one of nature's most stunning phenomena, also whispers, adding another layer to its mystery. Springs flow because of underground water pressure. When water seeps into the ground, it collects in porous rock layers called aquifers. If the aquifer is trapped between layers of impermeable rock, pressure builds. When there's a crack or weak point, water is forced to the surface, forming a spring. Some springs are small trickles. Others gush with thousands of gallons per minute. The water is often pure, filtered naturally through layers of rock. Springs have been sacred to cultures around the world. sources of life in dry lands, gathering places and symbols of renewal. And they flow constantly, year after year, fed by rain that fell months or even years ago, slowly making its way back to the surface. Dust storms can travel across continents. In desert regions, strong winds can lift millions of tons of dust into the atmosphere, creating massive storms that tower miles high. These dust storms, also called haboobs, can reduce visibility to zero and travel thousands of miles. Saharan dust regularly crosses the Atlantic Ocean, reaching the Caribbean and South America. This dust carries nutrients that fertilize rainforests and ocean ecosystems. It also affects air quality and weather patterns. What seems like a local event in one desert can have global impacts. The atmosphere connects us all, carrying particles, moisture, and energy across vast distances. Islands can disappear beneath the waves. Some islands are low-lying, just a few feet above sea level. As sea levels rise, these islands are at risk. Erosion, storm surges, and gradually encroaching water threaten to submerge them entirely. Some Pacific island nations are already losing land. In the past, islands have vanished completely, their names remaining only in old maps and memories. It's a slow tragedy, entire ecosystems and communities forced to relocate or adapt. Islands are fragile, beautiful, and increasingly vulnerable. They're early indicators of changes that will eventually affect coastlines everywhere. The Grand Canyon reveals 2 billion years of history. Standing at the rim of the Grand Canyon, you're looking at one of the most complete geological records on Earth. The layers of rock exposed in the canyon walls span nearly 2 billion years. At the bottom are some of the oldest rocks on the continent, ancient schist and granite. Above them, layer after layer of sedimentary rock tells the story of ancient seas, deserts, and rivers. Fossils mark the evolution of life. The canyon is a book, and the Colorado River has opened it for us to read. Each layer is a chapter, and together they tell the story of a planet constantly changing. Clouds can travel long distances. A cloud forming over the ocean might drift hundreds or thousands of miles before releasing its moisture. Clouds move with wind currents, sometimes staying intact for days. Weather systems carry them across continents. The water cycle is global. Rain falling in one place may have evaporated from an ocean on the other side of the world. Clouds are travelers, carrying water, energy, and even tiny particles like dust or pollen. They're messengers of the atmosphere, constantly moving, constantly changing, connecting distant places through the flow of air and moisture. Rock formations can tell time. Certain rock layers contain minerals that decay at predictable rates. By measuring the ratio of parent isotopes to daughter isotopes, scientists can determine when the rock formed. This technique, called radiometric dating, has allowed us to date the Earth itself about 4.5 billion years old. It's also used to date fossils, volcanic eruptions, and ancient artifacts. Rocks are clocks, ticking slowly, recording time in their atomic structure. And by reading these clocks, we've learned the age of our planet and the timeline of life's evolution. Tides affect more than just oceans. While we mostly notice tides at the coast, the moon's gravity affects all of Earth's water, including lakes and even groundwater. The effect is tiny in smaller bodies of water, but it's there. The solid Earth itself also experiences tides. The ground rises and falls by several inches each day due to gravitational pull. We don't feel it, but instruments can measure it. Even the atmosphere has tides. The moon and sun pull on everything, creating a rhythm that pulses through the planet, mostly invisible, but always present. Peat is partially decayed plant matter. In wetlands where water is stagnant and oxygen is low, dead plants don't fully decompose. Instead, they accumulate as peat, a dense, dark material. Over millions of years and under the right conditions, peat can become coal. Peat bogs store enormous amounts of carbon, acting as carbon sinks. When drained or burned, they release that carbon into the atmosphere. Peat is also used as fuel in some countries and as a soil conditioner in gardening. It's ancient plant life, compressed and preserved, a step between life and stone. Mountains can cast rain shadows. When moist air rises over a mountain, it cools and drops its moisture as rain or snow on the windward side. By the time it descends the other side, it's dry. This creates a rain shadow, a dry region in the lee of the mountain. Deserts often form in rain shadows. The Atacama Desert in Chile, one of the driest places on Earth, exists partly because the Andes block moisture from the east. Death Valley sits in the rain shadow of the Sierra Nevada. Mountains don't just stand tall. They control where rain falls and where deserts form. Glaciers can move boulders. As glaciers flow, they pick up rocks, some as large as houses. These boulders are carried along, sometimes for miles, and deposited when the glacier melts. These are called glacial erratics, rocks that don't match the local geology. They're evidence of past ice ages, proof that glaciers once covered areas now free of ice. Some erratics are precariously balanced on hilltops or sitting alone in fields, strange and out of place. They're travelers from distant mountains, carried by rivers of ice and left behind when the world warmed. Water vapor is the most important greenhouse gas. Carbon dioxide gets a lot of attention, but water vapor is actually the most abundant greenhouse gas in the atmosphere. It traps heat and helps regulate Earth's temperature. However, water vapor doesn't stay in the atmosphere long. It condenses and falls as rain within days. Carbon dioxide, on the other hand, can remain for centuries. The two interact. As the planet warms due to CO2, more water evaporates, creating a feedback loop. Water vapor amplifies the warming caused by other greenhouse gases. It's a key part of the climate system, and understanding it is essential to understanding how the planet's temperature is regulated. Hot deserts can freeze at night. Without moisture in the air to trap heat, deserts lose their warmth rapidly after sunset. In places like the Sahara, daytime temperatures can exceed 120 degrees Fahrenheit, but at night they can drop below freezing. This extreme temperature swing is hard on both plants and animals. Desert life has adapted to cope with these swings. Some animals are nocturnal to avoid daytime heat. Others burrow underground where temperatures are more stable. The desert is a land of extremes, and survival requires flexibility and resilience. The Earth's magnetic field protects us from solar wind. The sun constantly releases a stream of charged particles. If these particles reached Earth's surface, they would strip away the atmosphere and damage living tissue. But Earth's magnetic field deflects most of them, channeling them toward the poles where they create auroras. This invisible shield is generated by the motion of molten iron in the outer core. It's essential to life as we know it. Mars lost its magnetic field billions of years ago, and its atmosphere was gradually stripped away. Earth's field is not permanent either. It has reversed many times in the past, and it will again. But for now, it protects us quietly and constantly. Some rocks float on water. Pumice is a volcanic rock so full of air pockets that it floats. When volcanoes erupt explosively, gas bubbles get trapped in the cooling lava, creating a lightweight, porous stone. Pumice rafts, large masses of floating rock, can drift across oceans after eruptions. They sometimes carry marine life to new locations, acting as floating ecosystems. Eventually, the pumice absorbs enough water to sink, but for weeks or months, it rides the waves. A stone that floats seems impossible, but it's just another example of nature's endless variety. Rivers can run dry before reaching the sea. In arid regions, some rivers lose so much water to evaporation and human use that they never make it to the ocean. The Colorado River, once mighty, now often dries up before reaching the Gulf of California. The Yellow River in China has experienced the same fate during dry years. These rivers are called endorheic, ending in inland basins or simply disappearing into the desert. It's a stark reminder of how finite water is, and how human activity can alter even the largest natural systems. Clouds are made of millions of tiny droplets. A cloud might look solid, but it's made of countless water droplets or ice crystals, each one tiny, often less than 1/100th of a millimeter across. They're so light that air currents keep them suspended. When the droplets combine and grow heavy enough, they fall as rain. Clouds are not objects, but processes, constantly forming, evaporating, and reforming. They're visible evidence of water changing states, from vapor to liquid, carried by the wind, and returned to the ground. And every cloud you see is a temporary gathering, a brief congregation of droplets in the sky. The Earth's atmosphere is mostly nitrogen. We often talk about oxygen, but it makes up only about 21% of the atmosphere. Nitrogen is far more abundant, at about 78%. It's mostly inert, not participating in combustion or respiration, but it's essential for life. Nitrogen is a key component of proteins and DNA. However, most organisms can't use atmospheric nitrogen directly. Certain bacteria and lightning can fix nitrogen, converting it into forms plants can absorb. Without this process, life as we know it couldn't exist. The air we breathe is mostly nitrogen, a silent majority that supports the chemistry of life. Sinkholes can reveal hidden caves. When a sinkhole forms, it sometimes opens into a previously unknown cave system below. These sudden windows into the underworld have led to remarkable discoveries: underground rivers, unique ecosystems, and ancient artifacts. In Mexico, cenotes are sinkholes that expose groundwater. The Maya considered them sacred and used them for ceremonies. In Florida, sinkholes regularly reveal new cave passages. Each collapse is a reminder that beneath the surface, there's a hidden landscape, shaped by water over millions of years, waiting to be explored. Ocean currents act like conveyor belts. Water circulates through the oceans in massive currents driven by wind, temperature, and salinity. Warm water flows from the equator toward the poles. Cold water sinks and flows back toward the equator along the ocean floor. This circulation, called thermohaline circulation, distributes heat around the planet and influences climate. It's also essential for marine life, bringing nutrients from the deep to the surface. Disrupting these currents could have profound effects on weather and ecosystems. The ocean is not a still body of water. It's constantly moving, cycling, and connecting the world's seas into one global system. Crystals can form in hours or millennia. Some crystals grow quickly. In the right conditions, Salt or sugar crystals can form in hours, but most geological crystals take much longer. Quartz, amethyst, and other minerals grow over thousands or millions of years, one molecule at a time. The size and quality of a crystal depend on temperature, pressure, and the availability of material. Large, perfect crystals are rare and valuable. Each one is a record of the environment in which it formed, a frozen moment of chemistry and time. Soil erosion is one of the greatest threats to agriculture. Topsoil is the most fertile layer, rich in organic matter and nutrients, but it's also the most vulnerable to erosion. Wind and water can strip it away, especially when vegetation is removed. In some places, soil is eroding faster than it can form. This threatens food production and ecosystems. Farmers use techniques like cover cropping, terracing, and no-till farming to protect soil. Erosion is natural, but human activity has accelerated it dramatically. Protecting soil is essential to sustaining life, and it requires care, planning, and respect for the slow processes that build it. Clouds can form from aircraft exhaust. When a plane flies through cold, humid air, the exhaust creates condensation trails, or contrails. These are essentially artificial clouds made of water vapor and ice crystals. Contrails can linger for hours, spreading and sometimes merging with natural clouds. They affect climate by reflecting sunlight and trapping heat. The aviation industry is studying ways to reduce contrails because of their environmental impact. Every time you see a white line across the sky, you're watching a human-made cloud, a temporary mark left by flight. The stratosphere is where the ozone layer exists. The atmosphere has layers, and the stratosphere is the second one, extending from about 10 to 50 kilometers above the surface. This is where the ozone layer resides, a concentration of ozone molecules that absorb most of the sun's harmful ultraviolet radiation. Without the ozone layer, life on land would be nearly impossible. UV radiation damages DNA and causes cancer. In the 1980s, scientists discovered that human-made chemicals were depleting the ozone layer. International cooperation led to the Montreal Protocol, which phased out those chemicals. The ozone layer is slowly recovering, a rare example of successful global environmental action. Rivers carve canyons through persistent flow. The Grand Canyon, carved by the Colorado River, is proof of water's power over time. The river didn't force its way through the rock. It simply flowed day after day, year after year, for millions of years. Each particle of sediment carried away exposed fresh rock beneath. Slowly, the canyon deepened. It's still deepening today, though the process is too slow to see. Canyons are monuments to persistence, proof that time and patience can reshape even the hardest stone. And the river continues, indifferent to the grandeur it has created. Dew forms when surfaces cool below the dew point. On cool mornings, you might see droplets of water covering grass, leaves, and cars. This is dew, formed when surfaces cool overnight and water vapor in the air condenses onto them. The temperature at which this happens is called the dew point. Dew is not rain. It forms directly from the air, a gentle gathering of moisture. In dry climates, dew can be an important source of water for plants and animals. It's a quiet process, happening in the stillness of night, and by mid-morning, it's often gone, evaporated back into the air. Rocks can be folded like fabric. Under enough heat and pressure, deep in the Earth's crust, rocks become plastic. They can bend and fold without breaking. When these rocks are later exposed by erosion, You can see the folds, layers that curve and twist like ribbons. It's hard to imagine solid rock bending, but over millions of years and under immense pressure, even stone becomes flexible. These folds are evidence of tectonic forces, the grinding and collision of plates that shape the crust. And they're beautiful, natural sculptures created by forces we can barely comprehend. Waterfalls are temporary features. Waterfalls form where a river flows over a sudden drop in elevation, often where hard rock overlies softer rock. The soft rock erodes faster, creating the drop. But the waterfall doesn't stay in one place. It slowly migrates upstream as the rock beneath is worn away. Niagara Falls, for example, has moved about 7 miles upstream over the past 12,000 years. Eventually, waterfalls erode away entirely or are reduced to rapids. They're beautiful and dramatic, but they're also transient, temporary moments in a river's long journey. The atmosphere has weight. We don't feel it, but the air above us has mass, and that mass creates pressure. At sea level, atmospheric pressure is about 14.7 pounds per square inch. That means every square inch of your body has nearly 15 pounds of air pressing on it. We don't collapse because the pressure inside our bodies balances the pressure outside. At higher elevations, the air is thinner and pressure is lower, which is why your ears pop and why breathing is harder on mountaintops. The atmosphere is not weightless. It presses down on the Earth's surface with immense force. Wind erosion creates ventifacts. In deserts, wind-blown sand polishes and carves rocks into distinctive shapes called ventifacts. These rocks often have flat faces, sharp edges, and grooves, all oriented in the direction of the prevailing wind. There, sculptures made by the persistent abrading action of sand. Ventifacts are common in deserts and on Mars, where wind is a major erosive force. They're evidence of the wind's power, a slow but relentless shaping of the landscape. Lava tubes form from flowing lava. When lava flows, the surface cools and hardens while the interior remains molten. The lava inside drains away, leaving a hollow tube. Some lava tubes are large enough to walk through, and they can extend for miles. They're found in volcanic regions around the world. On the Moon and Mars, lava tubes are enormous and could potentially serve as shelters for future explorers, protecting them from radiation and temperature extremes. On Earth, they're fascinating geological features, tunnels carved by liquid rock. The Earth's crust is thinner under oceans. On land, the crust is typically 30 to 50 kilometers thick, but under the oceans, it's much thinner, only about 5 to 10 kilometers. This is because oceanic crust is made of denser basaltic rock, while continental crust is made of lighter granitic rock. Oceanic crust is also younger. It's constantly being created at mid-ocean ridges and destroyed at subduction zones. Continental crust, on the other hand, is ancient and less dense, which is why it floats higher. The difference between land and sea begins with the crust beneath them. Temperature inversions trap air pollution. Normally, air temperature decreases with altitude, but sometimes a layer of warm air sits above cooler air near the ground. This is called a temperature inversion. The warm layer acts like a lid, preventing the cool air from rising. Pollutants, smoke, and smog get trapped near the surface, leading to poor air quality. Inversions are common in valleys and basins, and they can last for days. When they finally break, the air clears and the pollution disperses. Until then, the sky is hazy and breathing becomes difficult. Fossils can be traces, not just remains. Not all fossils are bones or shells. Some are traces of activity, footprints, burrows, nests, or feeding marks. These are called trace fossils, and they provide insights into behavior, not just anatomy. Dinosaur footprints reveal how they walked and how fast they moved. Burrows show where ancient creatures lived. Coprolites, fossilized feces, tell us what they ate. Trace fossils are windows into daily life millions of years ago, preserved actions in stone, moments frozen in time. Sand dunes move like waves. Though they seem solid, sand dunes migrate. Wind blows sand up the gentle slope on the windward side. When the grains reach the top, they tumble down the steep leeward side. Over time, the dune moves forward, grain by grain. Some dunes travel dozens of feet per year. They can bury roads, buildings, and vegetation. In deserts, dunes are constantly in motion, flowing like slow, silent waves across the landscape. The moon stabilizes Earth's tilt. Earth's axis is tilted about 23.5 degrees, and this tilt gives us seasons. But the tilt isn't fixed. It wobbles slightly over thousands of years. If it weren't for the moon's gravitational influence, this wobble would be much more extreme, and Earth's climate would be far less stable. The moon acts as a stabilizer, keeping the tilt within a narrow range. This stability has been crucial for the development of complex life. Without the moon, Earth's climate might swing wildly, making long-term evolution difficult. The moon is not just a light in the night sky, it's a guardian of stability. Earthquakes release seismic waves. When an earthquake occurs, energy radiates outward in waves. There are several types. P waves, or primary waves, are the fastest and travel through solids and liquids. S waves, or secondary waves, are slower and only move through solids. Surface waves travel along the Earth's surface and cause most of the damage. By studying how these waves move through the planet, scientists have learned about Earth's internal structure. We've never drilled deeper than a few miles, but seismic waves have allowed us to map the crust, mantle, and core. Earthquakes, though destructive, are also tools for understanding the planet. Rivers create deltas by depositing sediment. When a river reaches the ocean or a lake, it slows down. The sediment it's been carrying settles out, building up over time into a delta. Deltas are often fan-shaped or branching, with multiple channels. They're incredibly fertile because of the rich sediment, and they support diverse ecosystems. But they're also fragile. Dams upstream can reduce sediment flow, causing deltas to erode. Sea level rise threatens to submerge them. Deltas are dynamic landscapes, constantly being built and reshaped by the river and the sea. The Earth's shadow causes lunar eclipses. A lunar eclipse occurs when the Earth passes directly between the sun and the moon, casting its shadow onto the moon. The moon doesn't disappear. Instead, it often turns a deep red or orange. This happens because some sunlight bends through Earth's atmosphere and reaches the moon, filtered by air and dust. The same scattering that makes sunsets red gives the eclipsed moon its color. Lunar eclipses are safe to watch and can last for hours. They're a reminder of the cosmic geometry, three bodies aligning in space, casting shadows across the void. Plants weather rocks. It's not just wind and water that break down rocks. Plant roots can do it too. As roots grow, they push into cracks, widening them. Some plants release acids that dissolve minerals. Lichens, which are fungi and algae living together, also produce acids that slowly eat away at rock surfaces. Over time, this biological weathering contributes to soil formation. Plants don't just grow in soil, they help create it. It's a slow partnership between life and stone. one that has been shaping the Earth's surface for hundreds of millions of years. Ice can carve U-shaped valleys. Rivers carve V-shaped valleys, narrow at the bottom and widening toward the top. But glaciers carve U-shaped valleys, wide and flat-bottomed with steep sides. This is because glaciers erode not just the bottom, but also the sides of the valley. When the glacier melts, it leaves behind this distinctive shape. Yosemite Valley is a classic example. Its steep granite walls and flat floor were carved by glaciers during the ice ages. U-shaped valleys are beautiful and dramatic, evidence of the immense power of ice. Thunder can echo off clouds and mountains. When you hear thunder, you're often hearing multiple sounds. The initial crack from the lightning bolt, followed by echoes and reflections off clouds, hills, and buildings. This is why thunder sometimes rumbles for many seconds. Each boom is a reflection, bouncing back to you from different surfaces. In flat, open areas, thunder is sharper and shorter. In mountains or cities, it rolls and echoes, creating a complex sound. Thunder is not one sound, but many, layered and reflected, the voice of the storm stretched across space. Hail forms in powerful thunderstorms. Hailstones begin as small ice pellets in a cloud. Strong updrafts carry them upward into colder regions where more ice accumulates. They fall, are caught by another updraft, and rise again, adding more layers. This cycle repeats until the hailstone is too heavy for the updraft to carry. Then it falls to the ground. Some hailstones grow to the size of golf balls or even larger. They can cause significant damage to crops, cars, and buildings. Hail is a sign of a strong storm, one with powerful vertical winds and intense energy. The water table is the underground boundary of saturation. Dig deep enough almost anywhere, and you'll hit water. The level at which the ground is fully saturated is called the water table. Above it, the soil is moist but not saturated. Below it, the pores and cracks in rock are filled with water. The water table rises and falls with rainfall and drought. Wells tap into it to provide water for drinking and irrigation. In some places, overpumping has caused the water table to drop dramatically, leading to shortages and land subsidence. The water table is invisible, but vital, the underground reservoir that sustains life. Rivers become braided when they carry too much sediment. Instead of a single channel, some rivers split into multiple shallow channels that weave and braid together. This happens when the river carries more sediment than it can transport efficiently. The excess sediment is deposited as bars and islands, forcing the water to flow around them. Braided rivers are common in glacial regions and dry climates. They're dynamic, constantly shifting and changing course. From above, they look like ribbons or veins, beautiful patterns etched into the landscape by water and sediment. Evaporation cools the surface. When water evaporates, it absorbs heat from its surroundings. This is why sweating cools your body, and why a breeze feels cooler when your skin is wet. Lakes, rivers, and oceans also lose heat through evaporation, which helps regulate Earth's temperature. On a hot day, evaporation from the ground and plants cools the air slightly. It's a natural air conditioning system, powered by the sun and the water cycle. And it's part of the delicate balance that keeps the planet habitable. Ice cores reveal past climates in detail. By drilling into glaciers and ice sheets, scientists extract cylinders of ice called ice cores. These cores contain layers that correspond to years, sometimes hundreds of thousands of years. Trapped air bubbles show past atmospheric composition. Dust and pollen reveal vegetation and volcanic activity. Isotopes in the ice indicate past temperatures. Ice cores are time machines, allowing us to see how climate has changed naturally over vast timescales. And they show clearly that current warming is unprecedented in speed and scale. Valleys can form without rivers. Not all valleys are carved by water. Some are tectonic, formed by the stretching and faulting of the Earth's crust. Rift valleys, like the East African Rift, are created when tectonic plates pull apart. The ground between them drops, forming a valley. These valleys can be hundreds of miles long and thousands of feet deep. They're often sites of volcanic activity and earthquakes. Over time, rivers and lakes may fill them, but the valley itself was formed by the movement of the crust, not by erosion. Fog and clouds are the same thing. The only difference between fog and clouds is altitude. Both are made of tiny water droplets suspended in air. Fog forms near the ground when the air cools and water vapor condenses. Clouds form higher up in the atmosphere. Walk to a high elevation on a foggy day, and you'll find yourself inside a cloud. Stand on a mountaintop and watch fog below, and you're looking down at a low cloud. The names are different, but the process is the same. Stalactites grow from the ceiling, stalagmites from the floor. It's easy to mix them up, but there's a simple way to remember. Stalactites hang tight to the ceiling. Stalagmites might reach the ceiling. Both form in caves from dripping water rich in dissolved minerals. The minerals precipitate out, slowly building these formations. They grow together, and when they meet, they form a column. Caves full of these features are breathtaking underground palaces of stone, shaped by water and time. Lightning heats the air to extreme temperatures. In a fraction of a second, a lightning bolt heats the surrounding air to about 30,000 Kelvin, roughly 5 times hotter than the surface of the sun. This extreme heating causes the air to expand explosively, creating a shock wave we hear as thunder. The channel of superheated air cools almost immediately, but for that brief moment, it's one of the hottest things on Earth. Lightning is not just light. It's a release of energy so intense it transforms the air itself. The Earth is widest at the equator. Because of its rotation, Earth bulges slightly at the equator and is flattened at the poles. It's not a perfect sphere, it's an oblate spheroid. The equatorial diameter is about 27 miles greater than the polar diameter. This bulge is caused by centrifugal force from the planet's spin. It affects gravity slightly, and it influences how satellites orbit. From space, you wouldn't notice the difference, but measurements show that Earth is subtly wider than it is tall. Earthquakes can liquefy soil. In certain conditions, an earthquake can cause water-saturated soil to behave like a liquid. This phenomenon, called liquefaction, happens when seismic waves shake loose sandy soil, increasing the pressure in the water between grains. The soil loses its strength and can no longer support buildings or roads. Structures sink or tip over. Liquefaction has caused significant damage in past earthquakes, especially in coastal or river, delta regions. It's a reminder that the ground we trust isn't always solid. Rainforests produce about a third of Earth's oxygen. Despite covering only about 6% of the land, tropical rainforests are oxygen powerhouses. Through photosynthesis, their dense vegetation releases vast amounts of oxygen. They also absorb carbon dioxide, making them critical in regulating the climate. But rainforests are being cut down at alarming rates. When they're lost, not only do we lose oxygen production, we also release stored carbon, accelerating climate change. Protecting rainforests is essential, not just for the species that live there, but for the health of the entire planet. Ocean waves are created by wind. When wind blows across the surface of the ocean, it transfers energy to the water, creating ripples. These ripples grow into waves. The stronger and longer the wind blows, the larger the waves become. Once generated, waves can travel thousands of miles across the ocean, carrying energy from distant storms. When they reach shallow water near shore, they slow down and steepen, eventually breaking. The crash of waves on a beach is the final release of energy that began far out at sea, driven by wind and carried across the deep. Volcanic soil is incredibly fertile. After an eruption, the land may seem lifeless, covered in ash and rock. But volcanic material is rich in minerals like potassium, phosphorus, and magnesium. As it weathers, it becomes some of the most fertile soil on Earth. This is why many agricultural regions are near volcanoes, places like Java, Sicily, and parts of Central America. Farmers have learned that despite the danger, volcanic land is worth cultivating. The soil gives back what the fire took away, and life returns, often more abundant than before. The Coriolis effect influences ocean currents. Just like wind, ocean currents are affected by Earth's rotation. In the northern hemisphere, currents curve to the right. In the southern hemisphere, to the left. This creates large circular patterns called gyres. The Gulf Stream, the Kuroshio Current, and others are all shaped by the Coriolis effect. These currents transport warm and cold water across vast distances, influencing climate and weather. They also carry nutrients and marine life, connecting ecosystems across ocean basins. The spinning of the planet shapes the flow of the seas. Geysers are rare because they require specific conditions. For a geyser to form, you need heat from magma, a reservoir of water, a plumbing system of cracks and tubes, and a constriction that allows pressure to build. All of these conditions must align perfectly. This is why geysers are found in only a few places on Earth: Yellowstone, Iceland, New Zealand, Chile, and Russia. Each eruption is a delicate balance of heat, pressure, and water. Break any part of the system, and the geyser stops. They're fragile, beautiful, and rare reminders of the heat beneath our feet. Permafrost stores massive amounts of carbon. In the Arctic, organic material frozen in permafrost has been accumulating for thousands of years. As the permafrost thaws, microbes break down this material, releasing carbon dioxide and methane. Scientists estimate that permafrost contains more carbon than the atmosphere currently holds. If even a fraction of it is released, it could significantly accelerate global warming. Permafrost is a ticking clock, and as the Arctic warms, the clock is ticking faster. What was once frozen and stable is now becoming a dynamic part of the carbon cycle. Sunlight powers nearly all life on Earth. Plants capture sunlight and convert it into chemical energy through photosynthesis. Herbivores eat plants. Carnivores eat herbivores. Almost every food chain starts with the sun. Even in the deep ocean, where sunlight doesn't reach, most life depends on organic matter that drifts down from the sunlit surface, or on chemosynthetic bacteria that still ultimately rely on energy from above. The sun is our power source, a constant, distant furnace that feeds the biosphere. Without it, Earth would be dark, frozen and lifeless. Rivers are the arteries of the land. They carry water, sediment, and nutrients from mountains to seas. They shape landscapes, create valleys, and build deltas. They provide drinking water, irrigation, transportation, and power. Civilizations have risen along rivers for thousands of years. But rivers are also fragile. Dams, pollution, and over-extraction can damage them. A healthy river is a flowing river connected to its floodplain, carrying its load and sustaining life along its path. Protecting rivers means protecting the land and the people who depend on them. And now, as we drift toward the end of this journey, let the weight of the world soften around you. We've wandered through mountains and valleys, across deserts and oceans, into caves and up into clouds. We've touched ancient ice, listened to the hum of the earth, and watched the patient work of wind and water. The earth is vast, old, and endlessly fascinating. It changes slowly, breathes deeply, and holds more mysteries than we could ever uncover in a single lifetime. And yet, even in its immensity, it feels intimate. The rain that falls on your window, the wind that moves the trees, the soil beneath your feet, all of it is part of the same system, connected, cycling, and alive. You are part of this planet, made of its elements, shaped by its rhythms, sustained by its generosity. The oxygen you breathe was made by ancient organisms. The water you drink has traveled through countless forms. The ground you stand on was built over billions of years, one grain at a time. So, as you close your eyes, let yourself rest in that knowledge. You belong here. You are held by gravity, warmed by the sun, sheltered by the atmosphere, and connected to every living thing through the deep, quiet cycles of Earth. Let your thoughts settle like sediment in still water. Let your breathing slow like the rising and falling of tides, and know that the world will keep turning, the rivers will keep flowing, and the mountains will keep standing, patient and strong. Sleep well. And thank you for exploring with us tonight. The sand on beaches tells ancient stories. Every grain of sand on a beach has a history. Some grains were once part of mountains, broken down over millions of years. Others came from shells and coral, ground up by waves. Some traveled hundreds of miles down rivers. Others were carried by wind from distant deserts. Beach sand can be white, golden, black, or even pink, depending on its origin. Under a microscope, each grain reveals its journey, worn smooth or angular, clear or colored. When you walk on a beach, you're walking on the debris of continents, the remnants of ancient life, all gathered by water and time. Atmospheric pressure drops as you climb higher. At sea level, the weight of the atmosphere creates pressure. As you ascend a mountain, there's less air above you, so the pressure decreases. This is why your ears pop and why it's harder to breathe at high altitudes. There are simply fewer oxygen molecules in each breath. Mountain climbers must acclimate slowly, allowing their bodies to adjust. At the top of Mount Everest, atmospheric pressure is about 1/3 of what it is at sea level. The air is thin, cold, and unforgiving. Yet people climb anyway, drawn by the challenge and the view from the top of the world. Clouds can weigh as much as airplanes. A single cumulus cloud, fluffy and white, might weigh around 500,000 kilograms, about the same as 100 elephants or a large jetliner. The water droplets are tiny and spread over a huge volume, which is why they don't fall immediately. But the total mass is enormous. When conditions change, and the droplets combine into larger drops. That weight comes down as rain. It's hard to imagine something so light and airy being so heavy, but clouds are deceptive. They're massive, floating reservoirs held aloft by air currents and physics. Rivers are older than mountains. Some rivers are ancient, older than the mountains they cut through. This happens when a river establishes its course on flat land, and then the land slowly rises due to tectonic activity. The river keeps cutting downward as the mountains rise around it, maintaining its path. These are called antecedent rivers. The Green River, which flows through the Uinta Mountains in Utah, is one example. It was there before the mountains existed, and as they rose, the river simply carved its way through. It's a reminder that landscapes are always changing, and what seems permanent is often just a snapshot in time. Snow is an excellent insulator. Air trapped between snowflakes makes snow a good insulator. Animals like voles, mice, and insects burrow beneath the snow to stay warm in winter. The space between the ground and the snowpack can be significantly warmer than the air above. This layer, called the subnivean zone, is a winter refuge. Plants also benefit from snow cover, which protects roots from freezing. Indigenous peoples have long built snow shelters, igloos, and quinzees, using snow's insulating properties to survive harsh winters. What seems cold and harsh is actually a protective blanket. Landslides can move faster than cars. When a slope becomes unstable, whether from rain, earthquakes, or human activity, it can collapse suddenly. Landslides can reach speeds of over 100 miles per hour, especially if they involve a mix of rock, soil, and water. They're devastating and often deadly. The debris flows down valleys, burying everything in its path. Warning signs include cracks in the ground, leaning trees, and sudden changes in water flow. But often, landslides happen with little notice. They're a reminder that even solid ground can move, and that gravity is always at work. The ocean absorbs carbon dioxide from the atmosphere. Oceans are carbon sinks, absorbing about a quarter of the CO2 humans release. This helps slow climate change, but it comes with a cost. When CO2 dissolves in seawater, it forms carbonic acid, lowering the ocean's pH. This process, called ocean acidification, harms marine life, especially organisms with calcium carbonate shells like corals, mollusks, and some plankton. The ocean is doing us a service, but it's suffering as a result. Understanding this balance is crucial for protecting marine ecosystems and managing climate change. Tornadoes can form in minutes. Under the right conditions, a rotating column of air can develop quickly. When a thunderstorm has strong updrafts and wind shear, rotation begins. If this rotation tightens and extends to the ground, a tornado forms. The process can happen in less than 20 minutes. Tornadoes are among the most violent weather phenomena on Earth, with winds exceeding 200 miles per hour. They're also localized and short-lived, typically lasting minutes to an hour. But in that brief time, they can cause catastrophic damage. Predicting tornadoes is difficult, which makes them particularly dangerous. Minerals give rocks their color. The color of a rock comes from the minerals it contains. Iron oxides create reds, oranges, and browns, the colors of rust. Copper minerals produce greens and blues. Quartz is usually clear or white. Feldspar can be pink or gray. The combination and concentration of these minerals determine the rock's appearance. Some rocks have bands of color, layers of different minerals deposited at different times. Others are speckled or uniform. rock color isn't just aesthetic. It tells geologists about the rock's composition and history, clues to how and where it formed. Glaciers store most of the world's fresh water. About 69% of Earth's fresh water is locked in glaciers and ice sheets. If all the ice on Earth melted, sea levels would rise over 200 feet, drowning coastlines and displacing billions of people. But glaciers are melting. As temperatures rise, ice is disappearing at an accelerating rate. This loss threatens water supplies for millions who depend on glacial meltwater. It also contributes to sea level rise. Glaciers are not just frozen water. They're reservoirs, climate records, and landscape sculptors. And they're vanishing. Stalactites can take 1,000 years to grow an inch. The formation of cave features is incredibly slow. Water drips from a cave ceiling, carrying dissolved minerals. A tiny bit of mineral is left behind with each drop. Over centuries, these deposits accumulate into a hanging structure. The rate depends on water flow and mineral content, but it's always slow. When cave formations are broken by vandals or careless visitors, centuries of growth are destroyed in seconds. Caves are fragile archives of time, and protecting them means respecting the patience it took to build them. The moon's gravity causes 2 high tides each day. Most people know the moon causes tides, but why are there 2 high tides? It's because gravity creates a bulge on the side of Earth facing the moon, but it also creates a bulge on the opposite side. The first is from the moon's pull. The second is from inertia, the tendency of water to keep moving in a straight line, while Earth is pulled toward the moon. As Earth rotates, different locations pass through these bulges, experiencing 2 high tides and 2 low tides each day. Evaporation happens even in winter. Water doesn't need to be hot to evaporate. Even ice and snow can sublimate, turning directly from solid to vapor without melting. This is why snow piles shrink on cold, dry days, even when the temperature stays below freezing. The sun's energy drives evaporation year-round. In winter, the rate is slower, but it never stops. The water cycle continues through all seasons, moving moisture from the surface to the atmosphere and back again in an endless loop. Sand dunes can sing or boom. In some deserts, large dunes emit low-frequency sounds when the sand slides. These sounds, sometimes called singing dunes or booming dunes, can be loud enough to hear from miles away. The exact mechanism is still debated, but it involves the friction and vibration of sand grains moving together. The sound is eerie and beautiful, a voice from the desert, proof that even lifeless sand can produce music when the conditions align. Mountains trap moisture on one side. When moist air encounters a mountain range, it's forced upward. As it rises, it cools, and moisture condenses into rain or snow. This creates lush, wet conditions on the windward side. By the time the air descends the other side, it's dry, creating a rain shadow. This is why you often find deserts on the leeward side of mountains. The Atacama Desert exists in the rain shadow of the Andes. The Mojave lies in the shadow of the Sierra Nevada. Mountains don't just block wind, they redistribute water. Ocean trenches are the deepest places on Earth. Trenches form at subduction zones where one tectonic plate dives beneath another. The Mariana Trench, the deepest, reaches nearly 36,000 feet below sea level. At that depth, pressure is over 1,000 times greater than at the surface. It's dark, cold, and seemingly inhospitable, yet life exists there, adapted to extremes we can barely imagine. Only a handful of people have ever descended to the deepest point. The ocean's trenches are among Earth's final frontiers, less explored than the surface of the moon. Rivers meander because of erosion and deposition. A river naturally curves because water flows faster on the outside of a curve, eroding the bank, while it slows on the inside, depositing sediment. Over time, these curves become more pronounced, creating loops and bends. Eventually, a meander can become so extreme that the river cuts through, abandoning the loop and forming an oxbow lake. Rivers are constantly reshaping themselves, moving across the landscape in slow, sinuous patterns. They're never still, always carving new paths. Sunlight takes 8 minutes to reach us, but thousands of years to leave the sun. Light travels incredibly fast, but the sun is far away. Photons produced in the sun's core, however, don't travel directly to the surface. They bounce around inside the sun, absorbed and re-emitted countless times. This random walk can take tens of thousands to 1,000,000 years. Only when a photon finally reaches the surface does it make the quick 8-minute journey to Earth. The sunlight warming your face is ancient, born in the heart of a star long ago. Hot springs can host unique life forms. Some microbes thrive in boiling water, acidic pools, or mineral-rich springs. These extremophiles have adapted to conditions that would kill most organisms. They give hot springs their vivid colors, yellows, oranges, greens, and reds, creating natural art. Studying these organisms helps scientists understand the limits of life and offers clues about how life might exist on other planets. In the harshest environments, life not only survives but flourishes, painting the world with unexpected beauty. Ice sheets can be miles thick. The Antarctic ice sheet, the largest on Earth, is over 2 miles thick in some places. It contains about 90% of the world's ice and 70% of its fresh water. If it melted completely, sea levels would rise by nearly 200 feet. The ice is ancient, with some layers over 800,000 years old. Beneath the ice lies a continent, mountains, valleys, and lakes, all buried under immense weight. The ice sheet is a frozen archive, holding evidence of past climates and a glimpse into Earth's future if temperatures continue to rise. Wind can carry dust across oceans. Saharan dust storms lift millions of tons of particles into the atmosphere. These particles travel across the Atlantic, reaching the Caribbean, South America, and even North America. The dust provides nutrients to rainforests and oceans, fertilizing ecosystems thousands of miles away. It also affects air quality and can create hazy skies. Dust is not just a nuisance. It's a global traveler, connecting continents and ecosystems in ways we're only beginning to understand. Geysers erupt because of underground pressure. Water seeps into chambers heated by magma. As it boils, steam builds pressure. When the pressure exceeds the weight of the water above, it erupts, shooting water and steam into the air. After the eruption, the cycle begins again. Some geysers are predictable, erupting on a schedule. Others are erratic. Each geyser has its own personality, shaped by the unique plumbing system beneath it. They're temporary features, easily disrupted by earthquakes or changes in groundwater. Enjoying them now means appreciating their fragility. Ocean waves can travel thousands of miles. Waves generated by a storm in the Southern Ocean can travel across the entire Pacific, arriving at distant shores days later. These swells are smooth and regular, carrying energy over vast distances. Surfers watch for swells, knowing that waves arriving on their beach were born far away. The ocean is interconnected, and energy moves through it like ripples in a pond, spreading outward from every disturbance. Permafrost creates unique landscapes. In the Arctic, permafrost shapes the land in distinctive ways. Polygonal patterns form as the ground contracts and cracks during freezing. Ice wedges fill the cracks, creating geometric designs visible from the air. Pingos, ice-cored hills rise from the tundra. Thermokarst lakes form when permafrost thaws and the ground collapses. These features are fragile. As the climate warms, they're changing rapidly, altering ecosystems and releasing stored carbon. The Arctic landscape is a living, shifting mosaic, shaped by ice and time. Water has a high heat capacity. It takes a lot of energy to heat water, and it releases that energy slowly when it cools. This property moderates Earth's climate. Oceans absorb heat during the day and release it at night, keeping coastal areas temperate. They also absorb heat in summer and release it in winter, smoothing out seasonal extremes. Without water's high heat capacity, temperature swings would be far more severe. Water doesn't just sustain life. It regulates the environment, creating conditions where life can thrive. Mountains can create their own storms. When moist air rises over a peak, it can trigger thunderstorms. These storms form even when the surrounding areas are clear. Mountain climbers often encounter sudden weather changes, clear skies turning into lightning and hail within minutes. Mountains disrupt atmospheric flow, creating turbulence, clouds, and precipitation. They're not passive features. They interact with the atmosphere, shaping weather in complex ways. Fossils are usually found in sedimentary rock. Most fossils form in environments where sediment accumulates, like riverbeds, lake bottoms, or ocean floors. When an organism dies, it must be buried quickly to avoid decay and scavenging. Over time, minerals replace the organic material, preserving the shape. This is why fossils are rare in volcanic or metamorphic rocks, which form under conditions that destroy organic remains. Sedimentary rocks are time capsules, holding the remains of ancient life in layers that tell Earth's story. Clouds form around tiny particles. Water vapor needs something to condense onto a nucleus. These nuclei can be dust, salt from sea spray, pollen, or pollution. Without them, the air would remain supersaturated, and clouds wouldn't form. Each cloud droplet begins with a microscopic particle, a seed around which water gathers. In clean air, clouds are harder to form. In polluted air, they form more easily, but may be less efficient at producing rain. The particles we've put into the atmosphere change not just air quality, but also weather. Underground rivers can be huge. In some cave systems, rivers flow through darkness, carving vast passages. The Puerto Princesa's underground river in the Philippines flows for miles through a cave before emptying into the sea. These rivers are difficult to explore, cold, dark, and dangerous. But they're also beautiful, with formations, pools, and unique ecosystems. Underground rivers remind us that much of the planet is hidden, that beneath the surface, another world exists, shaped by water and time. Ice reflects sunlight, helping keep the planet cool. Ice and snow are white, reflecting up to 90% of the sunlight that hits them. This is called albedo. Dark surfaces like forests or oceans absorb more sunlight and heat up. As polar ice melts, it exposes darker water and land, which absorb more heat, causing more melting. This feedback loop accelerates warming. Ice isn't just frozen water. It's a climate regulator, a mirror reflecting the sun's energy back into space. Losing it means losing a critical cooling mechanism. Rivers can freeze from the bottom up. In shallow, fast-flowing rivers, anchor ice can form on the riverbed. This happens when supercooled water loses heat to rocks and other surfaces, freezing on contact. The ice grows upward from the bottom, sometimes forming thick mats that can block flow or break free and float downstream. Anchor ice is more common in clear, cold nights. It's a strange and beautiful phenomenon, ice forming where you'd least expect it, hidden beneath the surface. Soil color indicates its composition. Red or yellow soil usually contains iron oxides. Dark soil is rich in organic matter. Gray or blue soil may be waterlogged, lacking oxygen. White or pale soil often has low fertility or high salt content. Farmers and gardeners read soil color to assess its health and suitability. Color is a quick visual clue to what's happening underground, a glimpse into the chemistry and biology of the earth. Clouds can seed rain. In some conditions, clouds contain supercooled water droplets that won't freeze on their own. Adding a particle, like silver iodide, can trigger freezing, causing the droplets to grow and fall as rain or snow. This is called cloud seeding, and it's used to enhance precipitation in dry areas or to reduce hail. It's controversial and not always effective, but it shows that we can influence weather on a small scale. We're learning to nudge nature, though we must do so carefully and humbly. Caves are home to rare species. Many cave-dwelling creatures are found nowhere else on Earth. Cut off from the surface, they've evolved in isolation, adapting to life in darkness. They're often blind, pale, and slow-moving, relying on senses other than sight. Some feed on bat guano or organic matter washed in by water. Caves are fragile ecosystems. Disturbance can wipe out entire species. Exploring caves responsibly means protecting the life within them, life that has existed quietly for millennia. The atmosphere is mostly empty space. Air feels substantial, but it's mostly empty space between molecules. At sea level, air is relatively dense. At higher altitudes, the molecules spread out and the air becomes thinner. In the upper atmosphere, molecules are so far apart that it's nearly a vacuum. Yet this thin layer of gas is all that stands between us and the void of space. It's a delicate shell, protecting, warming, and sustaining life on a rocky planet spinning through the cosmos. Rivers are highways for nutrients. As water flows from mountains to the sea, it carries dissolved minerals, organic matter, and sediment. This material nourishes ecosystems along the way. Floodplains are fertile because rivers deposit nutrient-rich silt. Estuaries are productive because rivers bring nutrients from the land. Blocking or polluting rivers disrupts this flow, starving downstream ecosystems. Rivers are not just water. They're arteries of the landscape, transporting the materials that sustain life. Wind shapes plants. Trees and shrubs in windy areas often grow asymmetrically, leaning away from the prevailing wind. This is called wind flagging, or krumholtz in extreme cases. The constant force of wind damages buds and branches on the windward side, while the leeward side grows more freely. The result is a sculpted, one-sided appearance. These trees are living wind vanes, their shapes recording the direction and strength of the wind over years. They're adapted, resilient, and beautiful in their asymmetry. Rainbows can appear at night. When the moon is bright and rain is falling, you might see a lunar rainbow or moonbow. It's much fainter than a daytime rainbow because moonlight is reflected sunlight and far less intense. Moonbows often appear white or faintly colored to the human eye, though long exposure photography can reveal their colors. They're rare and magical, a reminder that nature's beauty doesn't stop when the sun sets. Volcanic eruptions can cool the planet. Large eruptions inject sulfur dioxide into the stratosphere, where it forms tiny droplets that reflect sunlight. This can lower global temperatures for months or even years. The eruption of Mount Pinatubo in 1991 cooled the planet by about 0.5 degrees Celsius. The effect is temporary, but it demonstrates how powerful volcanic events can influence climate. Volcanoes are not just local disasters. They're global events, capable of reshaping weather patterns around the world. The ocean is layered like a cake. Seawater varies in temperature and salinity, creating distinct layers. Warm, less dense water floats on top. Cold, salty water sinks to the bottom. These layers don't mix easily, which is why the deep ocean is cold even in tropical regions. Ocean currents help mix the layers, redistributing heat and nutrients. Understanding these layers is crucial for studying climate and marine ecosystems. The ocean is not uniform. It's a complex, three-dimensional environment, each layer with its own characteristics. Earthquakes can trigger tsunamis. When an earthquake occurs under the ocean, it can displace vast amounts of water. This creates waves that travel across the ocean at high speed. In deep water, tsunamis are low and fast, barely noticeable. But as they approach shore and the water shallows, they slow down and grow taller, sometimes reaching heights of over 100 feet. Tsunamis are devastating, capable of traveling thousands of miles and striking coastlines far from the earthquake's epicenter. Early warning systems have saved lives, but the best defense is awareness and preparation. Snow crystals form around a nucleus. Just like raindrops, snowflakes begin with a tiny particle. Water vapor freezes onto this nucleus, building outward in a hexagonal pattern. The shape depends on temperature and humidity as the crystal falls. Slight changes in conditions create different patterns, which is why snowflakes are so varied. But they all share six-fold symmetry, a consequence of the molecular structure of ice. Each snowflake is a tiny geometric wonder, a visible expression of invisible forces. Soil microbes recycle nutrients. Bacteria, fungi, and other microorganisms break down dead plants and animals, releasing nutrients back into the soil. Without them, organic matter would pile up and nutrients would be locked away. These microbes are the unsung heroes of ecosystems, working invisibly to keep the cycle of life turning. Healthy soil is full of microbial life, and protecting it means protecting the foundation of agriculture and natural ecosystems. Wind can erode rock faster than water in deserts. In dry regions where water is scarce, wind becomes the dominant erosive force. Sand carried by wind acts like sandpaper, abrading rock surfaces. Over millennia, wind carves intricate patterns, arches and hoodoos. It's a slow process, but in the absence of water, wind is patient and persistent. Desert landscapes are shaped as much by air as by anything else, proof that erosion takes many forms. The Earth's magnetic poles wander. The magnetic North Pole is not fixed. It moves slowly over time, drifting across the Arctic. Currently, it's moving from Canada toward Siberia at about 30 miles per year. This wandering is caused by changes in the flow of molten iron in the outer core. Compasses must be updated to account for this movement. The magnetic poles have even reversed completely many times in Earth's history. We don't know when the next reversal will happen, but it will, and it will temporarily weaken the magnetic field, exposing us to more solar radiation. Lightning can strike upward from the ground. Most lightning travels from clouds to the ground, but sometimes it goes the other way. Upward lightning typically strikes tall structures like towers or skyscrapers. It occurs when the electric field is strong enough to initiate a discharge from the ground up. These strikes are less common but just as powerful. Lightning is not a one-way street. It's a connection between earth and sky, bridging the gap with a flash of energy. Rivers are younger than they seem. While the valleys they carve may be millions of years old, the water flowing through them right now is recent. It fell as rain days, weeks, or months ago. Rivers are constantly renewed, always flowing with fresh water. The river is both ancient and new, a path carved by time but filled with the present moment. This duality is part of their beauty, a connection between deep history and the living now. And so, we come full circle once more. The Earth, patient and vast, continues its slow dance through space. It spins, it orbits, it shifts and settles. The tides rise and fall, the winds blow and rest. The water cycles endlessly, from sea to sky to land and back again. You've traveled with us tonight through layers of stone and air, through time and space. You've seen how the planet builds itself, breaks itself down, and builds again. How it holds life in a delicate balance, regulated by forces both gentle and immense. Everything you've heard tonight is happening right now. Somewhere, a glacier is calving, a geyser is erupting, a river is carving deeper into stone. The Earth never stops. It's always moving, always changing, always becoming something new while remaining deeply, fundamentally itself. And you, resting here, are part of all of it. Your breath moves air. Your body holds water that has traveled the world. Your bones contain minerals forged in ancient seas. You are not separate from the earth. You are an expression of it, a temporary arrangement of its materials, alive and aware and connected to everything. So let that connection comfort you. Let the knowledge of deep time soothe your worries. Let the patience of mountains remind you that change is slow, that processes unfold over vast spans, and that your place in this moment is exactly as it should be. Rest now in the arms of the world. Let the earth hold you as it has held countless others before. Let gravity pull you down into softness. Let the darkness be kind. And know that when you wake, the planet will still be here, turning steadily, breathing slowly, carrying you through space on its ancient, patient journey. Sleep well, traveler. The Earth will keep watch. And thank you once again for sharing this quiet time together. Good night.